I managed to log out this time, fellas. Okay. All right, guys. So let me put on a video here, and I'll be back. I'm gonna go grab some food, real quick. And we'll put on a video. I think because we want to work on Kraken drives, I want to work on Kraken drives in Kerbal today. I think Nerva is probably the correct video to show.
The moon, closest neighbor to Earth. Presently the focus of man's greatest scientific adventure. The first celestial...
Oh yeah, you guys should probably look at the screen, huh? That would probably help. Anyway, fun Minecraft. For the people that are here for Minecraft, I play Minecraft every Saturday in the early, basically in the afternoon. Yeah, and we work on that fun project. But yeah, I hope you guys enjoyed it. Let's switch it over to Kerbal, and I will be back in about 20 minutes. The moon, closest neighbor of Earth. All right, be back in a little bit.
The moon, closest neighbor to Earth. Presently the focus of man's greatest scientific adventure. The first celestial body that will be explored by man. Landing men on the moon will be a truly great achievement, but only the beginning of a new era in space exploration. No one can predict the exact missions that will follow in the years and decades ahead. But the most exciting possibilities will require the acceleration and deceleration of very heavy loads, such as the maneuvering of large Earth-orbiting spacecraft. The transportation of large amounts of equipment and supplies to the lunar surface, and the sending of heavy spacecraft to the planets. Today's missions are being accomplished with rockets that burn chemical fuels. But chemical fuels are heavy, and the cost of putting each pound into Earth orbit is very high. Nuclear rockets, when perfected, can provide the same propulsion energy with less overall weight. They will expand our ability to explore space. This is the story. This is Saturn V, the most powerful launch vehicle being built by the United States. A three-stage rocket that will place the Apollo spacecraft in the vicinity of the moon. The total weight of Saturn V is about 6 million pounds. Its three stages have chemical engines that burn fuel to generate thrust. The first and second stages provide most of the energy needed to put the third stage and the payload, about 250,000 pounds, into Earth orbit. At present, only chemical rockets can provide the high thrust needed to do this job. The third stage accelerates the payload to the velocity needed to get it to its destination. Here, travel time and payload weight are determined by the efficiency with which the propellant is converted into thrust. By substituting a nuclear third stage for Saturn V, the velocity of a given payload can be greatly increased, cutting travel time for some missions in half. This is particularly important in sending deep space probes to Jupiter and beyond. Or if shortening travel time is not essential, propellant weight can be traded off for an increased payload weight. This is important for a lunar supply mission, Earth orbital operations, and some unmanned missions to the planets. Why is the nuclear rocket so much better than the chemical rocket? In rocket propulsion, exhaust velocity determines propulsion efficiency. At a given temperature, the lighter the exhaust gas, the higher the exhaust velocity. And the higher the exhaust velocity, the more thrust is generated for each pound of propellant consumed per second. The nuclear rocket merely heats hydrogen, the lightest element of all, and expels it at tremendous velocity. Chemical rockets burn fuel to produce exhaust gases that contain heavier elements. So at the same exhaust temperature, the exhaust velocity is much lower, and each pound consumed per second produces less thrust. Rocket efficiency is stated in seconds of specific impulse. This refers to the time in seconds that 1 pound of propellant will deliver 1 pound of thrust. The higher the seconds of specific impulse, the greater the propellant economy. Our best chemical rockets of today are limited to a specific impulse of about 450 seconds, and only slight improvement can be expected. On the other hand, full-scale nuclear reactor tests have achieved 800 seconds, and laboratory tests promise even more, perhaps as much as 900 seconds. This means the nuclear rocket, with its lightweight, high-velocity exhaust, will use propellant about twice as efficiently as chemical rockets. This, then, is the principal advantage of nuclear propulsion.
It was at the AEC's Los Alamos Scientific Laboratory, high in the mountains of New Mexico, that the first steps were taken. Here, in the mid-1950s, scientists set about to determine if nuclear energy really could be used to provide rocket propulsion. Theoretical studies and early experimental work revealed many problems that would have to be solved. Problems in reactor design, material, radiation, structures, control, to name but a few. The nuclear rocket was found to be feasible. A series of experimental reactors was planned to convert theory into workable hardware. Optimum reactor designs were worked out by analysis. Prototypes were built. A comprehensive test program was started. These reactors, called Kiwi, were to be used to prove out design and operational concepts. They would be built only for ground testing. All Kiwi power tests took place at the Nuclear Rocket Development Station at Jackass Flats, Nevada. Here in the desert, scientists and engineers checked the actual performance at various power levels and for various time periods. Each experimental Kiwi reactor was received in sections, assembled and checked out in a special reactor maintenance, assembly, and disassembly building called simply RMAD. When the reactor was ready for testing, it was placed nozzle up on a special rail car and delivered to the test stand a mile or so away. This car could be controlled from a remote station. Liquid hydrogen from nearby storage tanks was pumped through the reactor. First tests were begun in 1959 and were run to the 100 megawatt level, about 1/10 of Kiwi's ultimate goal of 1,000 megawatts. Later tests, beginning in 1962, operated at the full 1,000 megawatts. Films of these early tests show the flaming torch on the test stand that burns off the hydrogen exhaust gas and prevents an explosion hazard to the test facilities. Upon completion of these tests, each reactor, by then radioactive, was transported by remote control back to the RMAD building for disassembly and inspection. Here, men working behind shielded walls used remote-controlled manipulators to remove the components for careful checking and analysis. Each test firing added information that helped scientists evaluate the reactor's performance and enabled them to make adjustments and corrections before the next reactor was assembled. But not all tests showed perfect performance. In this one, for example, the flashing in the exhaust gas indicated a structural breakup caused by excessive vibration. Extensive redesign and testing were needed to correct the flaw. And in this test, a hydrogen leak caused a fire on the test stand. Again, a correction was made. Each test brought the scientists a little closer to the performance they were seeking, until finally, in September 1964, the 8th Kiwi reactor was brought up to full power and held for 8 minutes. And a few weeks later, it was restarted and operated at full power for 2.5 minutes. Specific impulse, about 750 seconds. This concluded the Kiwi test series. It had proved that a nuclear reactor could be built that would power a spacecraft.
The next step, already underway, was to develop complete engine technology. This project was called NERVA, Nuclear Engine for Rocket Vehicle Applications. It was to be a combined industry-government effort headed by the Space Nuclear Propulsion Office, a joint NASA and Atomic Energy Commission activity. The principal contractors were to be Aerojet General Corporation and Westinghouse Astro-Nuclear Laboratory. The NERVA technology reactor, given the letter designation NRX, was essentially the same as Kiwi, but now the contractors had to extend its lifetime and put it into an engine configuration. Here is how the nuclear rocket engine will work. The reactor is a solid core, heat exchange type, cylindrical in shape. Fission of uranium atoms in the core is the source of heat. A reflector made of beryllium surrounds the core. The core consists of many graphite elements impregnated with the uranium-235 fuel. The core contains a number of channels running down its length. Hydrogen passing through the channels picks up heat generated by the fission process. The channels are coated with niobium carbide, a material which resists the corrosion that would occur if the hot hydrogen were allowed to come into direct contact with the hot graphite. The hydrogen is stored in a liquid state to achieve the lowest possible volume. The flight model will use about 1/3 of a million gallons for a 30-minute firing. To start the engine, the cold liquid hydrogen at minus 420 degrees Fahrenheit moves through a pump down to the nozzle, through internal passages in the nozzle walls, and back up inside the reactor pressure shell and reflector. This cools the nozzle, the reactor shell, and the reflector, and at the same time warms the hydrogen. The hydrogen then passes through the hot fuel elements where it is heated to about 4,000 degrees Fahrenheit. From there, it is expanded through the nozzle to provide thrust. The bleed line carries some of the hot hydrogen back to drive the turbo pump. The whole engine system is amazingly compact for a nuclear power source. The reactor works through fission of uranium-235, which constantly emits nuclear particles called neutrons. When reflected back toward the reactor, these particles will set up a chain reaction, generating terrific heat. The heat is controlled by rotating rods installed in the beryllium reflector around the reactor. The rods are also made of beryllium, but one side is coated with boron, which absorbs neutrons. Initially, the rods are turned so the boron side is toward the fuel elements, and sufficient neutrons are absorbed to prevent nuclear fission from starting. Beryllium reflects neutrons. By turning the beryllium side toward the elements, a point is reached where sufficient neutrons are reflected for fission to begin. The amount of heat produced depends upon the position of the rods. Heat increases as more of the beryllium side turns toward the core. When the desired rate of heat production is reached, the rods are turned back to stabilize it. Heat decreases as the rods are turned back. When the boron side absorbs enough neutrons to halt the fission process, heat is no longer generated. These rods can be operated by remote control.
Test facilities for engine components were built near Sacramento, California. The problem? Get adequate performance with minimum weight. The pump must move huge quantities of liquid hydrogen under pressure at minus 420 degrees Fahrenheit, while the hydrogen-cooled nozzle must expand high-pressure gaseous hydrogen at 4,000 degrees to low pressure. The reactor was designed to meet the structural requirements of ground handling, launch, and spaceflight. In a late 1965 test, it operated intermittently for an hour, including 16 minutes at full power. But in that test, as in all reactor tests before it, the hydrogen had been forced through the reactor by test stand pumping facilities instead of its own turbine-driven pump. In early 1966, the new technology reactor and the chief engine components, including the turbo pump, were assembled for test. It was called a breadboard because they were not arranged as they would be in an actual engine. It would be the first self-starting test, and it was a vital step in the nuclear propulsion concept. This engine test model started perfectly and increased to full power, proving that a nuclear rocket could be started by its own pump. During a 2-month period, it was started and stopped 10 times and operated at different power levels for a total of 110 minutes, 28 minutes at full power. Technology had now advanced to the point where performance limits could be extended. Work was already underway to increase reactor power and operating time. In February 1967, this reactor, the Phoebus 1B, was operated at a power level roughly equivalent to 75,000 pounds of thrust. And in December 1967, this reactor, the NRX A6, was operated at full power for an hour. Also in 1967, a new test stand was completed that would permit a test engine to be fired nozzle down into a vacuum chamber below, at least partially simulating the space environment. In early 1968, the first ground test engine was mounted in the new stand. Its success was a new milestone along the long road leading to a flight engine. Heavy shielding was used in this test engine to protect some of the components from intense radiation. In flight engines, all components will be radiation hardened and less shielding will be needed. These tests will complete the technology for a nuclear rocket engine for application to space missions of the late 1970s and beyond.
Its thrust will be approximately 75,000 pounds. For missions that require higher thrust, 2 or more of these engines may be used in a single stage, or several engine stages may be assembled side by side. This versatility will give us the capability to perform a variety of advanced missions.
Someday, a manned trip to Mars and return may become the mission assignment. Exactly how it would be carried out depends upon a number of factors. But here is one way it might be done with nuclear rocket propulsion, using the technology developed for earlier missions. Using several Saturn V launch vehicles, components of the huge spacecraft would be placed into Earth orbit and assembled. Separate nuclear stages might be provided for each major step of the mission. The first stage might consist of 3 clustered rockets for departure from Earth orbit. 2 other nuclear stages consisting of 1 engine each would be used in the vicinity of Mars. The first stage cluster fires to accelerate the spacecraft to the velocity needed to get to Mars in the time that was decided upon, say 200 days. At burnout, the first stage cluster is jettisoned and goes into orbit around the sun. Mid-course correction is made by chemical rockets. About 200 days later, the space vehicle approaches Mars. There it is slowed down by a single nuclear rocket and enters an orbit around the planet. The used second stage is put into a higher Mars orbit than the space vehicle. A chemically powered module departs for the planet's surface.
Ando, yeah, it's so simple that back then. Just do it, dude. That's what I love about. That's what I love about the '60s, dude. Like, not like the whole '60s, like as a decade, but just people overall. It's like, you know, we talk about going to a mission. We're doing a mission to Mars. We talk about going to Mars nowadays. That's a hard thing to do, right? That's the first thing that pops in everybody's head. Oh, it's really difficult. Back then, they were like, yeah, so let's do it. We know it's hard. We get it. Let's go. I love that. I love that can-do freaking attitude, man. That's a great way. That's a great way to look at life. You don't sit there and whine about how hard it is. Go freaking get it done. You know the challenge. You know what's involved. Get it done. I love it. I love it. It's just casually just showing how a Mars mission would work. And you know they would have done it.
Men from Earth will set
if Apollo had kept going, they would have done this. This would have been done easily. They did nuclear aircraft carrier on Mars. Yeah. Right? Yes, and really, what a waste.
For the return trip, the module is lifted by chemical power back into a Mars orbit, where it docks with the main space vehicle.
Let me see, Jonathan.
The men transfer to the main craft and jettison the module, leaving it in an orbit around Mars.
Oops.
A third nuclear rocket accelerates the vehicle for the return trip.
Would it be on Mars by now? Yeah. We'd be exploring the belt right now if Apollo had kept going. If Apollo had kept going on its natural course, yeah, Vin, we would, dude, we would, I don't know, we'd probably be past the belt by now. Like, I'm talking about, like, okay, so this isn't even like keep NASA's funding at like 4% of GDP. This is just if we just kept going with the Apollo program, I don't think we'd be like to Pluto by now. But we would probably be at Mars, yeah. At the very least, Mars or the belt, yeah, we'd be there. We'd have like a moon base right now, a couple hundred people on it at any given time. Yeah, easily. Oh yeah. And it was in the middle of the Cold War, so military expenses were prioritized too. Yeah. Yeah, but Ando, you know, I think a shining feather in the U.S.'s cap, dude, is that when Eisenhower, the president in the 50s, when he went to make NASA, he made it a very, he saw, like Eisenhower, like a lot of people, all right, a lot of people know, if you know a little bit about Eisenhower and his presidency, one of his farewell things, like towards the end of his presidency, he saw how the military-industrial complex could be dangerous. And a lot of people say, like, oh, Eisenhower he knew, man. Like, no, what he was, but they totally missed the context of the statement. The statement is that if we just keep spending on defense, and we keep spending on defense, and we keep spending on defense, it's never going to be enough. It's never going to be enough. We just need to be cognizant of that, because someone's always going to be like, oh, I can make a better gun. I can make a better way to blow ourselves up, etc., etc. That's what he was warning against. He was warning against getting into an arms race with the Soviet Union, which is exactly what happened anyway. It's almost like he knew what he was talking about. The guy that oversaw the buildup of military armaments during World War II is warning how this could be a slippery slope. That guy might know something about this, but I digress. But the cool thing is that, you know, when he went to make NASA, he made NASA a civilian organization. And they took a bunch of, so at that point in the 50s, there was the NACA, which was the National Advisory Committee on Aeronautics. NACA was NASA's predecessor, but they were really only working on planes and stuff. They weren't necessarily working on space. But he took the NACA, and then he took the Army Ballistic Missile Agency, and a couple of other programs, and made them into NASA, right? But the idea is that we would peacefully explore space really can be attributed directly to him. Because the Air Force wanted to put a base on the moon. The U.S. Air Force wanted to put a strategic outpost on the moon. Basically, we'll put it there, get there before the Soviets, so they won't put a base on the moon and mine the moon, etc., etc. But that, like I said, that's a feather in our cap. Eisenhower's decision to basically make NASA a civilian organization, you know, that was very smart. Very smart. It wasn't JFK, Driados. It was Dwight Eisenhower. We need more money to science than defense. I mean, I understand the gist of what you're saying, but I wholeheartedly agree. I think 2022 is a pretty good example as to why we spend so much money on defense. Yeah. You guys could say, oh, we should just live in a perfect world where there's no fighting. Yeah, that's not happening. Yeah, that's not, like, I'm sorry, I don't mean to be a realist on this one, because space, the outlook that you need to have for space is it needs to be inherently optimistic, right? But also, that's not happening. As long as there are lunatics out there, there's always going to be one, Ando. There's always going to be one. Like, I said this back in late February. Where are all those people that shout that we, you know, where are all those people that say, like, oh, we spend too much money on defense? Yeah, where are those people at right now? Oh, geez, when nuclear war just inadvertently pops out of nowhere and starts knocking on your door, all those tree huggers shut the hell up, don't they? I mean, you could say I'm wrong, but it's funny because, you know, now that people have gotten bored of what's going on in Ukraine, you know, it's back to, oh, we shouldn't make weapons. But for a second there, people had like a coming to Jesus moment of clarity, and they're like, oh yeah, no, okay. You know? If only they could find the right salami lid. If we could find the right salami lid, we would achieve world peace. 95. And like I said, I choose to be a little bit realist when it comes to that because, dude, humans are like that, man. There's always going to be someone that whines about a free lunch. I've talked about this. And that's an important thing to understand, especially if you're younger. We can't do perfection. It doesn't work. If you've ever watched the first Matrix movie, you know exactly what I'm talking about. Did you know, Mr. Anderson, that the first Matrix was designed to be a perfect world? Without pain and suffering, it was a disaster. No one would accept the code, and entire crops were lost. Now, don't get me wrong. I'm not saying the Matrix is the end-all, be-all for human social behavior, right? But that is a very good point. It's a very interesting thing to understand that humans are not perfect. We're not perfect, and if we try to be perfect, we're gonna end up killing each other. Like that, it almost always ends in death. So it's better to acknowledge it and work around it, like an engineer would work around a problem. Work the problem. You don't just sit there and pretend the problem doesn't exist, right? And think that you can just use hopes and dreams to just will away the fact that we're imperfect, right? That is an exercise in futility. That's not going to work. That won't work at all. Every time someone's done that, people end up dying. It's true. And the crazy thing is that it's agnostic to social structures. It happens every time through human history. So acknowledge that we're imperfect and move on. Work around that problem, right? Striving for perfection, Petty, is a thing that we should be doing. We should be striving for perfection because we can always get better as a species, I think. I think that's the right way to look at it. Trying to be striving to be perfect as opposed to being like trying to achieve that level of perfection, right? Like if you set like this is perfect, this is what we should be, as opposed to just we should be better, right? Those are two different things. But wouldn't you want to have a perfect internet connection? Yes, Dunpeel, I would. Humans are not internet connections last time I checked. Yes. A good internet connection would be pretty preferable for me. I don't know about you. I was also of the opinion that military spending is fine, but we need to be spending more on dreams so there's actual hope. Agreed, Ando. Agreed. Yeah, no, and don't get me wrong. Like, WWW in chat was saying like, oh, we should spend more on science and less on defense. No, I don't think it's mutually exclusive. We should spend more on everything. I said moron. We should always strive to be better. But, I'm not against defense spending, to be honest. I sleep pretty well knowing that we have a bunch of nukes pointed at anybody that would want to launch a nuke at us. That's a standoff like that is a pretty damn good deterrent. Nobody wins. The only winning move is not to play. Have you heard of the Universe 25 experiments? It's really cool and kind of ties into this. No, I haven't, but what's that about? Day-to-day engineers need to learn to make do with the good enough because perfect never gets stuff done. Bingo. The only winner is Gandhi in Civ 6. Yep. Heard from some economy expert that this war ended the peace dividend. The last decades were the lowest percentage of defense spending, which is good for other branches like medicine and education. Drianos, you're right, and that, the nuclear age, so 1945 to present, is literally one of the most peaceful times in human existence. Humanity has grown, and we've reached unparalleled levels of success as a civilization, as opposed to any point in history. It is literally one of the most peaceful times. Don't get me wrong, that doesn't mean we aren't without war. War always rears its ugly head, but it is a peaceful time. The Cold War was one of the most peaceful times in human existence. That's even taking into account like the Korean War, Vietnam, Afghanistan, and Afghanistan again. You get the idea. To be fair, the more you spend into science, the more you'll have to spend into defense to safeguard the technology. Eagle, I think they go hand in hand, personally. I actually, in high school, once upon a time, this was 15, 16 years ago, I wrote my junior thesis on this, on defense spending, and I did a lot of research. I got an A on that, because it was something that I wanted to do. Rockets, defense spending. And I cited rockets as an example as to why defense spending does increase the scientific meta. Oh, absolutely. The internet, the modern internet infrastructure is because of defense spending, because of the DARPA net, because we were looking at a way to be able to retaliate in a nuclear strike with a countrywide web, operative word, of computers that could be all interconnected to each other, so we could coordinate an effective nuclear retaliatory strike. That was the original reason why the internet came to be. Don't get me wrong. Defense spending did not invent the idea of linking multiple computers together. Alan Turing did that. But in the same way that Benz invented the first automobile, Henry Ford put the automobile on the map. Turing invented the internet. But defense spending is the reason why we have the modern internet today. Computers, very good example. Modern computing can be attributed to the Apollo program. That's actually science. That's scientific funding. But the scientific funding for NASA for the Apollo program from the 60s was rooted in defensive doctrine to show that we're better than you because we can go to the moon and you can't, right? I mean, hey, whatever floats your boat. If that's why we want to go, if that's the reason we go to the moon, I don't care. You're missing the point. We get to go to the moon, you know, like. Isn't rocket science classified as weapons science? Yeah. But does that mean that every rocket is designed to put a warhead somewhere, Eagle? No. Falcon 9 ain't designed to put any weapons, any offensive weapons anywhere. Interesting, goalie. Yeah, Dunfield, something like that. Universe 25 is a utopia study with mice in perfect conditions that shows that even with excess food and stuff, the mice still turn crazy and go to cannibalism. Altio, yeah, mammals, any biological organism, and to keep in mind, I'm not a biologist, but I do know a little bit about this, but I ain't no expert. We have. Our brain is basically three parts, right? We have a stem, you have your limbic part of your brain, and then you have the cortex, right? There's three big parts. The interesting thing is that, like a dog, for instance, you know, humans have a stem, limbic part of your brain, and the cortex. Dogs have that too, but the cortex is nowhere near as big. They're not as big brained as we are, but they still have the same limbic brain. Any mammal does. You have the stem and the limbic function, or the not limbic function, the limbic part of your brain. The limbic part of your brain is feelings and stuff. That's where all that comes from. The cortex up here is what makes us human, right? And the cortex, like on the very top up here, that's the motor cortex. That's makes you do this, right? And obviously, humans do human thing. We're capable of complicated, rational thought, right? Dogs can't do that because they don't have that part of their brain. It's not as developed as ours is, but it is similar, which is very interesting, right? But at the end of the day, we're still animals because we have that limbic function there. We have that limbic part of our brain. Most animals have that. Crazy, right? It's like our brain is like an amoeba with like a frog brain and then a monkey brain stacked on top of each other. It's weird, but it is cool. Very interesting. How that thing came to be is, you know, we talk about how SpaceX has rapid prototyping design. This was rapidly prototyped over millions of years, so it's gotten to a pretty damn good iteration. There's still some problems with it, though. Fun fact, insects have brains in their legs. Well, insects aren't mammals. The stream is not only interesting, it improves my English a lot as well. Didn't know the brain parts in English. Yeah, no problem, Fruity. I try to speak. I know there's a lot of people that watch overseas. I try to speak when I'm explaining stuff. I speak very slowly and very concisely, so that's for people that are ESL. English is a second language. I do that for you guys. I do that very, very much on purpose. But yeah, I mean, like I said, because we have that limbic function right there. You know, we're never going to be perfect. We're always going to search for the bad, even if we have a utopian scenario. That limbic part of our brain, the part of our brain that's like deep core emotions and stuff, like the need to eat, for instance. You ever try to lose weight and you're like, you try to lose weight and then you're hungry all the time and then you end up gaining weight? That's your limbic function, because your cortex is telling you, that part of your brain, the human part of your brain is telling the frog part of your freaking brain that you shouldn't eat as much because it's not healthy. But the frog part of your brain goes, well, you haven't eaten in a while. What do you mean? You haven't eaten in a while. You got to eat. You got to eat or you'll die. You got to eat or you'll die. No. Eat more. Eat more. No, don't try to eat less. Eat less is bad. You'll die if you do. Doesn't make sense, right? Because, like I said, freaking frog brain. Or lizard. I mean, yeah, it's funny because we're not, lizards are amphibians. They're different, but I'm in this exact situation right now. Being perfect is boring anyway. Definitely appreciate, no problem. I got you guys. Yeah, no problem. Farfugio. I mean, I give everybody that's not American crap, but I'm just kidding. I don't mean that for real. But except British people, who throw you in the harbor. But they already understand what I'm saying anyway, so it doesn't matter. Harbor. You know, our brain naturally, that limbic part of your brain always is trying to look for something wrong. This is, so like, if anybody out there is a content creator or a streamer, you could get 1,000 compliments, 1,000 people saying, oh, you're awesome, dude. And then you could have one person that says, you suck, you're a moron. And your brain will focus on that. This happens with content creators. I see it all the time, and I'm not above it either. It happens to me too. You know, you could be doing excellent at work, for instance, and then you make a mistake and you're like, oh God, no, I screwed up, everybody hates me. That's your brain your brain does that. It does that. It's always going to focus on the bad. That's how our brain works, because like I said, we evolved over millions of years to be the apex predator on this planet, right? We went from, nomadic, throwing spears at things, right? Like, I mean, some humans still do that. I'm not trying to be a dick. Like, to, weapons and, space flight and all this other, I mean, not just those, but you get the idea. We mastered our domain. But that doesn't mean that we didn't evolve before all that to get to the point where we could, automate things or use mechanics to our advantage, right? We didn't get to that point. We didn't fight to be the apex predator so we could get to this point where we could, like, mechanize everything, right? Like the Industrial Revolution, for instance. I mean, it's not just that. There's stuff before that, like the Romans. We've talked about that before. We didn't get to this point by, not, like, watching our back, right? Can you imagine how much... Dude, being on Earth even, like, 100 years ago would be like playing a, like, terrible survival game nowadays. Like, think about it. It's crazy. Even 100 years ago. 100 years ago, the common cold can kill you. Like, you could die very easily from the flu or pneumonia or the cold or dysentery. You ever play Oregon Trail? It's a pain in the butt. It's like a terrible survival game. We're not perfect. We're not perfect because the crucible that we were forged in on this freaking rock, on this planet, made us very paranoid. It's just how we evolved. That's why we're here today, because we're paranoid. We're still paranoid. The only way we can achieve peace is if everybody points a gun at everybody else. Figuratively. Like on a geopolitical scale. The Russians have nukes pointed at us. China has nukes pointed at us. Russia has nukes probably pointed at China. China has nukes pointed at Russia. We have nukes pointed at everybody. Like, we're in a Mexican standoff. That's the only way we've been able to achieve peace thus far. Ironic, isn't it? Or COVID. Yeah. $1900. You have diabetes? Dead. Yeah. Anyway, guys, let's load up some KSP. Let's play. But yeah, like I said, that's an important thing to understand, So long story short, to take this back to where we were, you just gotta have a can-do freaking attitude. You can't sit there and focus on the bad. You sit there, you focus on the bad, you don't get anything done. You have to have a little bit of a can-do attitude. You have to master that. You have to master those limbic functions, and that is a hard thing to do. Once upon a time, they called that growing up. It's hard to do. It's hard to be in control of your emotions like that. That's a very difficult thing to achieve. I still have problems with it. Like, look at racing last night, you know? Like, I got upset because I couldn't do what I wanted to do, you know? Like, it happens. COVID is actually a very good example of how well we can work together. Yeah, I mean, if we have a common enemy to defeat, and oh yeah. You know, you gotta keep you cool. I'm not gonna say you need to be in touch with your feelings, but you need to understand when that limbic part of your brain is telling you something. You know what I mean? You gotta understand what it's telling you and why. That's a really important part to growing up. Search your feelings, you know it to be true. Actually, that's what, in Star Wars, right? If we want to switch to Star Wars lore, that's what being a Jedi is all about. Acknowledging those emotions, acknowledging that you're going to have bad emotions and dealing with it. Sith are the freaking man-children that can't control their damn emotions. You know what I'm saying? They're just grown-up toddlers. I mean, look at how much of a whiny bitch Anakin became after Episode 3, right? Ew, it's cringe. Gross. Cringe. You're just gonna strangle people when stuff doesn't go your way? That sounds like a temper tantrum to me, and I'd probably get choked out for saying that. Cringe. Cringe, bro. Cringe. No. Cringe, bro. Cringe. The coughs are coming back. All right. For space news, note the time of this video. The object behind the red rope here is supposedly a Starlink V2. Behind the red rope, huh? Dude went on a whole rant about sand. Who does that? A psycho. Somebody who isn't in touch with their damn emotions. Jeez. Oh, yeah. Dude, look at how big that Starlink satellite is. Is that Elon? That is Elon. The guy that looks like a freaking rugby player. He's a big dude. Interesting. That satellite's a damn unit. Oh, yeah. Yeah, we'll watch some parts of this in a little bit. Guys, we were talking about like fusion and stuff when we were playing Minecraft today. So you know what I want to do? I want to I want to go and mess with something that we haven't messed with in a little while. Every once in a while, I'm jonesing to mess with these things that we made in KSP a little while back. Now, did you see that? You see what I just showed you right there? Let's go. Huh. A Triton that got into space? Interesting. Where are we going? Where are we going? We're going... Ah, here we go. You guys see this? Oh. Huh. Change topic a bit. Have you seen the Apollo FM radio reverse engineering? Really smart stuff. I haven't. No. That's really cool, though. I'll check that out. And video must says they remove the torch igniters from Raptor 2. Don't need it. You think it's because the Raptor's chamber pressure is high enough to cause an auto ignition? I don't know, man. There could be just an integral, or not integral, an internal torch igniter in there. But yeah, I don't know. There could be a bunch of different things. Yeah, we're a little ways away from the sun. He called it the secret south. So, if you guys aren't familiar with this, this is the Nautilus, okay? The Nautilus, you might be wondering how it's going 341,000 meters a second. That's because the Nautilus, by far and away, is one of the most capable spacecraft in KSP that I've ever made. So here, let me show you how it works. So, I want to go back to the sun. We want to go back to the solar system. Jeb and Bob are a little ways away. How far are we away from the sun? Yeah, we're a little ways away. So, I am going to put on infinite fuel here just because we don't have enough to get them home. I don't think 22 units of oxidizer is enough to get us back where we need to be. But, yeah, we'll put on infinite fuel this time around. Actually, you know what? Yeah, infinite fuel will be fine. Okay, so the Nautilus is a pretty cool little vehicle. Here, let's get in here. Okay, so let's set that as target. And watch. So we have our regular impulse drives, right? We have that. That won't get us very far. You know what will? Watch this. Torque limiter is high. RPM limiter is up. Watch. Engage. So I know it doesn't look like much, but some of you might notice that, well, that velocity is going down pretty fast. Hey, Adam, what's going on? Yeah, we need to get back over there. It's a little ways away. Engage the silent drive. Oh, Bob got knocked out. So the drive mechanism that you see here is a little bit up. Jeb's reaching the G-load limit. All right, let's knock him out. Jeb needs to cryo sleep for a little while. Oh, yep, Jeb's out. The OG Kraken Drive stream is still easily top 5 days on here. The rate of innovation was so crazy between anybody. Right on, Scary. Hell yeah, man. Yeah, those were fun streams. You know, I decided we've been jumping back into KSP, and I've been working a lot on the mission mode stuff, and the mission mode stuff is fun. But let's take this to the next level. Let's have a little bit more fun today. I think with hybrid tech, dude, we can make a Kraken drive that puts this one to shame. Is it moving? Is it moving? Yeah, here, let me check the accelerometer. The accelerometer is reading 13 times the force of gravity. Yeah, we're accelerating. Or, well, to be perfectly clear, we're decelerating. we're accelerating, or I should say decelerating, at such a speed that it literally knocked Jeb and Bob out. They're in cryo sleep right now. So, if you notice, we're going a little fast. Let's push it. Oh, nope, we bounced a little bit. 15 G's, constant acceleration. Are we ever going to make a Grissom 2? I don't know, maybe. This is the most brutal cryo sleep of all time. Yeah. Let's call it involuntary sleeping. Yeah. And they don't suffer from narcolepsy either. You know what I'm saying? How does this work? Kraken drive, man. So the Kraken drive is basically, we basically figured out a way to make an Epstein drive in KSP. We're, like I said, we're a little ways away, but let us decelerate here and boost back towards Kerbin, and I'll show you. 16 G's, almost 17 G's. Did it launch from Kerbin using this drive? I actually launched it with a conventional rocket. So, yeah, give me a moment here. We'll, turn that into a ring and it looks like the warp drive? Yeah. Well, MotoKid, yeah, I think we can do better. If only I had something relative to pass by, I could show you guys what I'm talking about here. This is how Mystery Goo is made. Yep. What's in the payload bay? Oh, nothing. Oh, just a robotic arm. Cool. Are the spinny bits needed or just for show? Everything that you see that's moving on this is absolutely needed, and I'll get more into it in a second. I'll get more into as to why in a moment here. Yeah, it's absolutely needed. The only thing that isn't needed is the light. The light changes when you accelerate. Like if you look, I'll undo the drive here for a second. We'll spin down the drive, right? Watch. See, now I'll ramp it up again. See how the lights change? Engaged. Warp drive engaged. Engage. Here we go. The drive wasn't spinning at maximum capacity there. Now it is. Oh, coolant leak. We had a reactor breach there for a second. So, basically how this drive works, dudes, is we have a bunch of landing gear in there. If you see the landing gear, right, we have landing struts. And the landing struts have no spring and damper no spring and damper attributes. How this works is we basically push a grip pad at these struts and compress them. You compress them fully. Compressing them fully imparts insane acceleration on your vehicle. For the For Kerbal players, that's called a Kraken Strike. We took the idea, or that force that gets applied during a Kraken Strike, and we found a way to harness that force and turn it into a drive. That's exactly what this is. Enter the Kraken Drive. Kraken Drive is basically an Epstein drive in stock KSP that basically, for only the cost of spinning this thing around, allows you to pretty much go anywhere. Now, why is it spinning? Spin stabilization helps the landing gear seat correctly up against the grip pad. Yep. Yep. In the time that I've been explaining about this drive here, we've probably decelerated by about 20,000 meters a second. Yeah. Yeah, it has insane amounts of delta V. Now, I'm not going to lie to you. Right now, I do have Infiniprop on, because they would be stranded out here. 18 liquid fuel will get you a good amount of delta V from this drive, but it won't get you home. It could get you probably to Joule. Yeah. Does it work if you turn off the RCS? It should, but it might destabilize a little bit. We have to have the RCS on if the drive is pushing past 10 Gs. If we stay right at around 10 Gs right there, yeah, the SAS can compensate just fine. But the RCS is there for stabilization purposes. What's your acceleration? The accelerometer is right there on the right side of the nav ball. It's an Expanse reference, Taradra. So where are we headed? Well, we're a good ways away from the solar system. We should, like, Elu is over there. Yeah, I'm decelerating, and I'm going back home. The last half wasn't. Yes, it was. Yes, it was. Solomon Epstein is the guy that created the faster-than-light drives in the Expanse universe. What did you find out there? Oh, there's a lot of space. A lot of room for activities. Yeah, not faster than light. I just didn't have a better way to explain it. I hate that we have to outgas. There are some things that we can fix with this drive, but yeah. See, this was the best that we could do. But I think, like I said, I think we can make a better drive. There's ways to make a better Kraken drive than this. And I think we can really figure it out with hybrid tech. Hybrid tech could be the key to making a drive that could basically get you to the moon in about 5 minutes. Have a secondary wheel spin in the opposite direction to counter the gyroscopic precession. Yeah, you see this whole thing out on the top that's spinning like crazy right here in the center of the ship? Yeah, what do you think that is? Tandem drives weren't more stable. They weren't. They actually, if you have two tandem drives, one could produce slightly differential thrust and the thing would spin out of control. This was the best way we figured out to stabilize them. They weren't more stable, Jacob. Dare you to EVA Bob? Nah, I'm good. Let's get back to the solar system. We have about 23 billion miles to go. Or 23 billion meters, not miles. Actually, no. We're... Oh, we're way more than that. 1 trillion. We're 1 trillion meters away. Yeah, we gotta... Yeah, we'll fix that. Can you put multiple drives in line to get more thrust? We tried doing that and it didn't like it, Tree. Like I said, we're gonna go back and we're gonna... I'll load up this craft file, but I needed a way to show people what this was. And, yeah. Here, let's go up here. Maximum drive strength. What's our acceleration? 15. Can we push it a little bit further? 16. 17. 18. 18 G's of acceleration. Dude, the SAS can't compensate. The RCS can't compensate. That drive is torquing this ship. I can't hold it. It won't hold. The whole ship is buckling under the torque. I'm not even kidding. I'm not even making up these damn words. That's exactly what's going on. The dilithium crystals, Captain. Alright, fine. We'll just spin stabilize the whole damn thing. Yeah, this is fine. This is fine. It's totally fine. Now try spinning. Historically, it's been shown to be a very good trick. Historically speaking. MGB! Woo! 45 months. Alright, we'll bring it back down to 10 G's of acceleration. 10 G's of acceleration is 98 meters a second per second. Yeah. That's fast. Or, so what would 98 meters a second be? 320 feet per second? Yeah. We're doing 320 feet per second acceleration. It's pretty fast. They're not turning into goo nearly, they're sleeping. Yeah. Here, let's push it again. Try to get this thing up. 20 G's of acceleration. Drive broken yet? Nope, it's taking it. Nah, 17 is too much, Tessa. No, isn't this the spaceship from Captain Future if you know the anime of the 70s? No, it's not. This is just something I threw together that looks cool. Push it to 22. I think the drive will break if we do. Yep, it broke. Back it up. Keep in mind, fellas, we're still just decelerating. We're still moving away from the sun at 200,000 meters a second. Or 208,000 meters a second. We still haven't stopped. We're hitting the brakes right now. We were going 380,000 meters a second. Or that's what it was, right? Something like that. That should make one shaped like the event horizon. Well, with some optimizations to the drive, guys, I should be able to put it in a bigger ship, and we should be able to scale it. Aerobrake that beast. If we hit any atmosphere right now, Viscous, the ship would immediately obliterate itself. Is the Nautilus on Kerbal X? I forget. If it is, it's called like HDP prototype or something is what I called it. Heavy duty something or other. Hawking drive. When I did it, I just put two drives in line spinning in opposite directions. I could never get that to work exactly right, Mank. Ah, good. We're under 200,000 meters a second now. I'll keep this window pegged so you can see how fast we're going. Gotta move this stupid thing. Why is its orbit not elliptic around the sun but looks like a straight line instead? Have you seen how fast we're going? We're going 178,000 meters a second. That's escape. That is beyond escape velocity for our solar system. We're decelerating at 17 Gs. 17 Gs. Here, let me do some math. 9.81 times 17. We're decelerating at 166 meters a second per second. Seventeen times the force of gravity here. Okay, we've slowed down about halfway from what we were doing originally. So how is this Kraken drive working? I'm pushing a grip pad with a hydraulic against landing gear. And in order to get the landing gear to seat correctly against the grip pad, I spin the entire drive. It's spin stabilization. It helps Kerbal understand that it helps Kerbal understand how to push on all the legs equally with the grip pad. But it still has some issues. Like this drive can be pushed basically to about here before it starts to freak out. I think we can make it better, Ono. I think I can get it to work. I could get this thing to work with hybrid tech. I want to explore that today. We were talking about fusion drives and making like sci-fi stuff, you know, in the future. If we had a fusion drive, a magnetic containment fusion rocket engine, we could get to the moon in like 5 minutes. We were talking about that in like Minecraft, and now that made me want to play. It made me want to play KSP and start screwing around with the Hawking drives. So that's what we're gonna do. Just gotta turn my air conditioner on. So this isn't working? This one was, Jaka, yeah. I don't know how you got the "so this isn't working" from that. Docking port drives are much more stable. They're much more stable if you don't like accelerating at 15 Gs. 154,000 meters a second and decelerating. We have to get back home. Oh, a fusion joke. I get it. I get it. Does Kerbal have oxygen? No, not unless you have a mod. Gotta say, I'm hyped for interstellar travel in KSP2. Yeah. Fusion joke. I see that sticking around for a long time. When is KSP set to release as of right now? Raptor. I found the prototype Mark II drive. It is yeah. See, Tessa, we can. That's good. But I think we can make. I think we can do better with hybrid tech. Yeah, MGB. They're in cryo sleep. I'm gonna get it on my Xbox if it's on it, so I hope crossplay would be awesome. Why in the name of God would you play Kerbal on an Xbox? Why not? Because you're paying for a product that was designed that really should be on the computer. And don't get me wrong, like, you can play console games, I don't care about that. It's not about that. It's like, it would be like, I can't even come up with an analogy. Kerbal is just a complicated game. You need the freedom of a mouse and keyboard to really play this right. Because you want to play KSP but can't afford a PC like you 2 years ago. Oh. How's the spinning thing not breaking apart from the difference in temperature between hot sun and absolute zero? Because thermals in Kerbal aren't as hardcore as they are in real life, can it? We're almost done decelerating, by the way. But yeah, Kraken Drive, man. We're decelerating at 14.2 Gs. Are you playing RCS noise along with the music? No. The RCS noise is coming from the RCS that is... The heck is that? Kraken Drive. Spunklecraft, you ever play KSP and you ever load up like your moon base or something and something just blows up? Something that's sitting on landing legs just decides to pop. It just explodes. Ever have that happen? That phantom force? We made it into a drive mechanism. The same thing that makes crafts explode in Kerbal we're using to decelerate and accelerate around. It's a, we call it a Kraken Drive. Yeah, it takes the power of the Kraken strike and harnesses it into a drive mechanism. Yeah, thanks, man. I'm glad you like it. Would you consider one of these for mission mode? I don't know, someone. Dude, if we had these for mission mode, Kerbal would get real old real fast, I think. But it would be cool to design architecture around this, I will say. Did you know they ported Roller Coaster Tycoon 3 to the Switch? Neat. So, right now I'm completing a deceleration burn because we were shooting away from the sun at 350,000 meters a second or something. So we were going this way, and I'm turning us around. Now we want to go back to the solar system. Elu is over there. Yeah, we have to go back to the future. Oh, we're under 100,000 meters a second. Cool. And also, guys, hey, just try to keep it classy during the day. When I stream, I try not to curse. If you guys can do the same, I'd really appreciate it. But yeah, it is pretty freaking cool. How exactly are you controlling the acceleration since I don't see the throttle? Well, you don't use this. I have a hydraulic ram that's spinning right there, and it pushes a grip pad. See the grip pad right there? There's a hydraulic piece that's in here. It's inside of that rotor. Actually, no, the hydraulic is over here. It actually pulls the grip pad. When I hit H, it's bound to an action group, right? When we do that, we pull the grip pad into the landing gear, and the landing gear compresses. And when you fully compress landing gear in KSP, it doesn't stop applying force. The law of conservation of energy does not exist. The landing gear in KSP have a logarithmic amount of potential energy, meaning you're never going to fully compress the springs on landing gear. They can go past full compression, and when they do, you invert that logarithmic scale of force because of how they're coded in Unity, and you could just, you can accelerate. Yeah, it doesn't make sense. It violates conservation of energy. There's a couple Couple laws of physics here that we're breaking with this, but it works in KSP, so it doesn't matter. That's why I say, like, you ever load up a craft in KSP that's sitting on the moon on landing legs and you load it up and it shoots off into space? It's because you fully compress the landing gear. And when you get past full compression, once again, force is it's not, I don't think it's logarithmic, I think it's exponential. Force gets exponentially applied the closer you get to full compression of the spring, and then if you go after, it keeps getting applied on an exponential scale. So the more you compress the landing gear in KSP, if you can get it to zero, if you can get it to full bump, you're going to accelerate. If you can get it past full bump, you're going to accelerate exponentially faster. Like right now, we're going at 9 Gs. I don't have the drive completely engaged, but if we we move the control rod in and push down on that grip pad, we can go up to 14, 15, 16, 17, 18, 19. 19 Gs. Look at us decelerate. It starts to freak out. The gyroscopes fail. And the RCS doesn't stabilize us when we're up going that fast. This thing likes right around 15. Jeb and Bob are just sleeping. That's all. Yeah, there you go, Bob Lane. Right? Yeah, see. 78,000. What's the risk level of this going pop? So Spangle, what happens is sometimes if I go past 20 Gs of acceleration with this particular drive, dude, like, it's kind of cool because the drive has, like, operating parameters, right? I can keep accelerating, but if I accelerate too fast and we fully compress the landing gear can bump past the grip pad, and if they bump past the grip pad, the hydraulic applies more force to try and stay where it is, right? So the grip pads will push the hydraulic open and the hydraulic will expand and contract. I call it drive oscillation. The drive oscillation will short out your electrical system because the hydraulics in this game use electrical. It's an electro-hydraulic system with the robotics in KSP, right? So the more force that the hydraulic pushes with, the more electricity you're going to use. So if you push this drive past its operating limits, watch, I'll do it. Ready? See? Oh God! It'll short out your electrical system. Now, don't get me wrong, I have infinite electric on, but did you see? We shorted out the drive. And I think we even broke it a little bit, because not all the landing legs are pushing up against the drive. Oh, boy. Yeah, I may have broken this. See what I mean? There are operating parameters for this. It's not exponential. It really comes down to your design. Yep, we broke it. We're stuck. Yeah, that's in craft. I didn't do this on purpose. This is just, oh, we broke the landing legs. That's why it's not working. We broke the landing legs. Hang on, we'll see if we can repair it. Bob? Did you lose another Jebediah? Jeb. Do we not have an engineer on board? We just have a scientist. I don't think I can repair those. Huh. Okay, well, they're stuck. I'm just gonna recover that ship if you don't mind. Sorry if I inspired you to break it. Well, if I just sit here and say, oh, it could break, right? No one's gonna believe me. People will be like, yeah, okay, it's gonna break. No, it can break. Terminate. Don't worry, there's no permadeath on this save. We should have Jeb. No. Here, hold on. Let me. Where is it? Kerbals. Here we go. Yeah, we gotta go into difficulty settings. Here we go. Missing crews respawn. There you go. They will respawn. So how about we just... How long does it take to respawn? Oh, it doesn't take very long. I've never done that. I've never ever done that in KSP, believe it or not. I've never reverted a crew. Found the original prototype. This is the 5th anniversary of the K-Drive. Read the description on the craft blocks. Strimmer, do all these things that I want you to do when you're trying to play Kerbal. Good description. Alright. Alright. Alright, let's go. So, it goes fast. Can we make it better, though? I think hybrid tech would really, really make this drive work. So let me load up. I have a lot of craft files loaded in. That's why it takes a second.
Discovery, go at throttle up.
Kerbals don't die. They just rematerialize out of goop. Hey, Finos. 63 months. Streamer, keep on streaming. Okay, will do. Oh, yeah. We launched the ship inside of a fairing. I remember now. Do you literally not need traditional rockets to get to space with this thing? You should use a traditional rocket. You should use a traditional rocket to get it up into low Kerbin orbit. Using this thing in the atmosphere, is a poor decision. I can show you if you want. I don't know. It might actually it might not work anymore. Give me 1 second. With the hybrid tech, you won't even need to spin the drive, I think. Also, an atmosphere is fine. Just keep it under 2G. Yeah. There it is. I don't ever remember making this. Well, let's see what happens. Yeah, Finos, we figured out a way around that. Ah, Jeb and Bob are back. Neat. Oh, nope, there it goes. What have I done? My brains are going into my feet. Oh, that's the end of that. Yep, nope. That's why we don't do that. That was awesome. That was awesome. He's gone to plaid. Oh, nope, there's part of the drive. Yeah, that's gone. Yeah, we broke it. Smoke if you got him. Well, are we stopped? Good. How about a 5-minute break? Smoke if you got him. I don't think I got the payload bay. Well, no, I did get the payload bay closed in time. That's fine. Yeah, I don't think we have the Delta V to get. Oh, we did. Oh, wait, I still have infinite prop on. Hold on. Boop. Yeah, we still have the Delta V. We can make it. I actually saved the ship, mostly. Alright, here, let's try it again. Comb the desert! That's right. So, yeah, the drive does work. It works really well, actually. Yeah. Whoop. This one has 2 little spinning nacelles on the side. Interestingly enough. I want to try that again. Hold on. I want to try that again. I want to try it again. Let's try it again. We can do this. It's fine. It'll work. It'll work. Trust me. Would it work if you flew as high as possible before engaging the drive? Well, yeah, of course. Not good. Must gain airspeed. Must gain airspeed. Oh! Well, there goes the wings. The drive didn't engage. the drive didn't. It didn't drive. Huh. The drive didn't drive. Did you get over 400? I don't think we ever made it. Drive-int. Yeah. Yeah, that's what happened. I'm gonna put in a drive on a pod racer. Eh. It's altitude, dude. You have to go above 400. For whatever reason, it's very strange. You don't go above 400, it doesn't really work. Of course it won't drive, it's a plane. Alright, that's fair. Oh, that's probably why the drive didn't work, I'll be honest with you. Okay, we're above 400. Maybe it was speed too, Jack. I don't remember. Oh, nope, there it goes. Okay. All right. Slow down. Slow it down. There we go. Nice, steady acceleration. There we go. Okay, slow it down. Okay, alright, go. There we go. Just don't want to go above 1400. There we go. Just coast it for a second. Coast it. It's like cheat codes. Because we have no cheats enabled. Got them. There we go. Yeah, see, we're good. We're good. You good? I'm good. I didn't really mean to shut that or remove it from symmetry. Not that it matters, but. But yeah, we were down there a second ago. Gonna make a supersonic man out of you. We must get into orbit. Oh, the moon. The moon's right there. Yeah, any old school Kerbal player knows that when the moon comes over the horizon, that's when you start burning, right? Well, there's the moon, so... Yeah, we should probably do this like now. But we drain the EC. I didn't turn the fuel cells on. There we go. It's fine. No. I want to go to the moon. I don't want to go... Let's go over here a little ways. Man, we're heating up a little bit, huh? There we go. There we go. We're good. Yeah, we dipped into the atmosphere for a second there, Bob. That almost ended real good. Oh, Bob's getting sick. Yeah, see, we gotta change it just a little bit. There we go. Buzz the moon. Yeah, oh yeah, we'll be there in a second. But if we could just get rid of these drive oscillations, man. $10,000 meters a second. Hybrid bearings should do it. Gonna do something. Go faster. Okay, go slower. Well, we were down over there a second ago. Why do you need them to spin? I explained this to you already. Nearly, they need to spin so it seats correctly. If you don't spin the drive, it'll just spin you out of control. Also spinning, yeah, spinning is indeed a neat trick. Just got in. What's the mission? I'm doing something that I don't normally do. I'm messing with some of the sci-fi drives that we've made in the game. Look at our orbital velocity, Psycho. There we go. Maybe we should start slowing down. No, Kerbals don't worship the Kraken, they worship the hierarchy. The hierarchy is your defense. Hierarchy building rules are your 10 commandments against the Kraken. Kraken is like devil worship. About a quarter of the way there. Not fast enough. Go fast. Go faster. I said go faster. We must skim the surface of the moon. No. I said across the moon's nose, not up it. This was on the runway 13 minutes ago. Just thought I'd let you know. We should slow down. Yeah, we should slow down. Should we slow down? Yeah, let's slow down. Nah, it's fine. Why not? Oh, okay. All right. Let's flip her around. Yeah, let's enter the SOI first to see if we can slow down in time. I don't think we can slow down in time, but we'll see. Jeb forgot his wallet? Oh. Damn. There's nothing I can do about that. Where we're going, we don't need wallets. No, I want to fly by just because that's going to be cool. To the moon in real time. Not bad, huh? You know, part of me is thinking, like, it would be really cool. It would be really cool to, like, you know, somebody already asked it. Someone you actually asked it. It would be cool to develop a space program around this, around the Kraken drives. Like a Grissom that has a Kraken drive built into it. That would actually be really cool. Bob forgot his passport. Oh. Jeb won't get to ride whalers on the moon? Oh. Yeah, I mean, Chief, you said it. I think somebody else said it as well. But yeah. I mean, it would be cool. It would be cool. I wouldn't necessarily be against it. Grissom plus the Kraken would be a sight to see. Like, yeah, MGB, we use conventional rockets and conventional landers to, like, land down on the planets and stuff. We're inside of SOI. But, you know, we can zip over to, like, the moon in real time in 15 minutes. That'd be pretty cool. And that's what I mean. If we can develop a more stable version of this thing, it doesn't really inspire confidence, to be honest with you. This thing likes to freak out. You need the RCS to stabilize, etc., etc. I mean, we did do that a long time ago, yeah. Even a non-Kraken drive Grissom would be just awesome. Yeah, but Chief, you gotta be... yeah, that would be nice, dude, but yeah. Is that good for the mission? You know what I mean? Like, is that what we need? Oh, here comes the moon. Guys, we're not time warping, by the way. Just for what it's worth. Have you tried 2x drive cores? 2x drive core doesn't really work to... Oh my god. It doesn't really work to... Dude, this is gonna get... What's the Parasynthian is 10 kilometers. Alright, maybe we should start slowing down. Oh no. Oh no, oh no, oh no. Okay. Yeah! It's too close! No! Please! Yikes! Yikes! We're not time warping! Ah! Oh god! No! That's really freaking fast, man. Yep. We passed it! Stop this thing! We can't stop. It's too dangerous. We have to slow down for... Bull crap! I order you! Stop! Spin up the drive. Maximum spin. 10 Gs. Nope. It doesn't like it. Nope. It hates us. It hates us. Yep. We broke it. They've gone to plaid. Okay. That's cool. Alright. Can we make this more stable? That's what I'm wondering. People arrive, people leave. So that was Meep. Meep is pretty cool. Alright. Let me load up the Kraken Drive design, the Kraken Drive's craft file. This is why I like my Warp Tech engine that I made for the Blue Shift mod. Buzz the moon. Permission to buzz the moon. Negative, Jeb Rider. Lunar orbit is full. Here it is. Here's all the different prototypes that we were screwing with. 5 is the highest number I see. Hawking Prototype Drive 5A. There it is. Big firepower in a small package. Let's see. Let me think. How would we make this? Yeah, we're done, right? Yeah, we need to make the what's the name of the high-speed ship? Razorback is what it's... Razor Crest? Razorback? No, Razor Crest is Mandalorian. I'm trying to think, like... The Razorback is Expanse. Yeah, there you go. Hybrid tech, man. Hybrid tech. We don't even need the aft drive rotor. All right, let's go 5B. All right, so it looks like I have a drive rotor, and the drive rotor okay, I see how I made this. So I have the hydraulic is attached to the back of the drive rotor, and the landing gear is attached to the front of the drive rotor, and the grip pad should be on extreme grip. The grip pad is on extreme grip, and the hydraulic will pull the grip pad in and compress the landing gear, and then we spin stabilize the whole damn thing. Are your Kraken drives limited by the mass of the spacecraft? Believe it or not, MG, yes, they are. Kraken drives don't... This thing won't be able to move like one of my Grissoms around. It won't. It won't move it. It moves... This thing can move about a ship as big as the Nautilus, the one with the spinning things that you saw. Kraken drives, but theoretically, they could be scalable. You're limited... You're really limited by the strength of the landing gear. It's the stress tolerance. But interestingly enough, yeah, there's a typo in Kerbal. The stress tolerance of the LT5 landing strut is absurd. So you can push on it forever. We figured that one out. I remember. Oh, that one is too. Yeah, all three of those have a trillion stress tolerance. Interesting. Yeah. Yeah, you could theoretically do it with landing gear as well. I think it's the stress tolerance? I forget, to be honest with you. Okay. Okay, I got an idea. So, let's get rid of that. Let's get rid of that. Right? The entire thing is attached on a fairing. Okay. Get me the thermo bearing out. Let's get the thermo bearing out and let's see. So this thing is spinning on a rotor. The rotor likes to do this when you spin it. You saw it, and the ship just oscillates out of position. Because the rotor starts to do this. It's not perfectly balanced. Perfectly balanced as all things should be. So, a little while back, let's say a little while back, like 2016, we figured out a way to make hinges out of certain parts. Actually, I do want to start fuel cell. Yep. Okay, so there. Enable same vessel collision. Enable same vessel collision. And it used to be that you needed to have two different vehicles to make hinges and whatnot. Nowadays, that's not the case. Nowadays, we figured out ways to make hinges in the game. We figured out a way to make hinges in the game, and those hinges don't, those hinges can collide with each other, and with them being the same vehicle. That's why I'm binding enable same vessel collision to the right action group. The interesting thing about this, guys, is that if you use same vessel interaction on physics-less parts, they don't drift. They don't move around. They don't do any of that oscillations nonsense because they're physics-less. So now, let me attach another RCS block here, like this. And let me put that RCS bearing in there. Take this, disable the RCS, right? And now, that bearing right there should keep this whole thing in line. If I attached it to the fairing, which, yeah, that should work. That kind of relies on the fairing connection holding the whole thing together. Tessa bearings. Actually, Josh is the one that came up with this design. Josh Kernick in chat. He was here earlier. I don't know if he's still here. Right? So, there we go. So, I took that part off. Like, you got to go in here. You got to make sure you bind enable same vessel collision to an AG, like that, to an action group. Now, let's see what this does. I'm very interested. Oh, I gotta attach it to something, don't I? Keep in mind you may have to switch it to the stronger atmospheric sensor based hinge instead of the thermo hinge. Same thing, just a thicker collision box. It's not a bad idea, Jaka. Why not use spectrometers? The thermo hinge might be strong enough, dudes. It's possible. See what I mean with hybrid tech, dude? We have all dude, there's so much. Oh my goodness. There's so much potential here. Dude. All right. Well, let's take a look. So what I'll do is we'll take this thing. Give me an adapter or something. I don't know. Yeah, something like that there. Our old friend, the skipper. I'm gonna make this pretty quick. There we go. Jeb! Jeb! I got something for you. Jeb's like, You wanna go fast, Jeb? Uh-huh. Jeb, oh Jeb, I got a surprise for. Oh, he didn't fall for it. Damn. All right. Spin it up. Engage the fuel cell. If the fuel cell's engaged, that means we're good to go. Ready? Let's just close this up. Okay, ready? Come on. Come on. Push. Come on, push. Oh, 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 oh my God. Okay. Okay, 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 okay. What's wrong with this thing? Okay. There. Oh, it pulls it out. It pulls the bearing out.
Discovery, go at throttle up.
Yo, that thing is not spinning. It's not oscillating around, dudes. Yeah, that's exactly what I thought it would do. It's not moving around. It's not oscillating. I actually have an interesting idea, Tessa. What if we just took the housing and flipped it 180 degrees? I'm serious. What happens? It would prevent the drive from engaging. Would it though? Yeah, we might need to make a slide. The spectrometer might be a better solution. Alright, go fast. Wow. Dude, it... Oh my goodness. Okay, alright, stop. Whoa. Yeah, it stabilizes it out. It stabilizes it out pretty well, actually. Literally no... Like, did you see how clean that acceleration was? That was really good. We're going to the moon? Oh. Yeah, sure. Why not? Alright, let's see if we can get a nice clean engage here. Dude, I think it broke it, because look at that. I think the game is having trouble understanding what the hell that's doing. What is our acceleration right now? 19 G's of acceleration. Holy crap. It did what I thought it was going to do. Hold on. Can we push this? Can we push it? Hold on. 20. We're past 20. Easily past 20. 23, 24, 24, nice and stable. No freaking way. Unfreaking believable. That's not cruise safe though? What's not safe about it? I'm confused. They'll just go into hypersleep. Kill the spin. How stable is it? Oh, I don't know. Hang on. Let's try to stop it first. Ready? Rotor brake. Rotor brake should stop this thing. Okay. All right, let me time warp for a second. We're already going 20,000 meters a second, guys. Just thought I'd let you know. We're gonna be at the moon in 8 minutes. All right, I stopped it. Let me lock that out, Tessa, and we'll see what happens. Nah, it's got to spin. Let it spin. Spinning it stabilizes it. It's still stable. Oh my god. That's absurd. That is absurd, man. Wow, that's the... Dude. It is wobbling a little bit. I know what it's doing, though. It's the grip pad that's wobbling now. The grip pad's wobbling. If we stabilize the grip pad, this could be, like, perfectly balanced. Bring us in close. Yeah, Linux. We're using hybrid tech with a Kraken drive to stabilize the thing out. Oh my goodness, this thing is ridiculous. 22.8 G's of acceleration. This is some expanse stuff here, man. What if we hybrid tech the landing gear? No, you can't surface attach landing. You can't surface attach stuff to landing gear. Damn. Can we push it? 26, 27, 27 G's. Oh my goodness, we're going 50,000 meters a second. I'm gonna crash. We should turn around. Like now, we should turn around and slow down. Push it. Push it. 28. Nope. Pogo. 28. Oh, man. It started pogoing past 28. Yep, it broke. Gotta back off for a second. Oh, I'm losing it. We're losing it. Gotta bring it back. I think maybe Dude, look at how smooth that operation is. Even though it's pulling the bearing out, it's still acting like the bearing is there. It's doing something very strange with that physicless part. But here we are pushing 27 Gs. Once again, the drives have TWR. So 27 Gs with this really light little spacecraft means that we could push with this small drive. If I put it in a bigger craft, we could make a bigger craft accelerate at like 1 G. It is entirely dependent on mass. Oh my god. Oh my goodness. Oh my. Oh no, wrong way. Oh no, stop. We're dead. I heard the moon is really nice this time of year. Some of the debris bounced off the moon. Oh, it's going 31,000 meters a second. Holy crap, dude. Erased from existence. All right, let's make some modifications here. Open this up again. What else could we screw with? We could screw with that grip pad. Hold on. How much does that craft weigh? Oh, I didn't get it. Okay, we can surface attach to the grip pad. And now give me another one of these and attach it to the fairing, right? Can it fit in a Mark III cargo bay or inside of a fairing for a larger craft or atmospheric craft? Yes. The drive technically is just what you see on the screen. That's it. This is just a housing for it. And the counter gyros to prevent your spacecraft from spinning. But this drive might be so smooth that the twin contra-rotating drives might work. Could you try time warping while it's outside of the hinge? I'm wondering if it maybe runs a check on where the part is and it constrains the... I don't understand exactly what you're saying, but it sounds that maybe, I don't know. Well, the salami lid. You forgot about the salami lid, 95. It ain't gonna fit. Won't fit. The salami lid ain't gonna fit. Let's try something a little bit different here. I want to see what this thing does pushing an insane mass around, just out of curiosity. Alright, now we're gonna need something to scoot this thing up there. Ain't gonna fit. Salami lid ain't gonna fit. Just cheat it to orbit for testing purposes? But Tessa, the salami lid is not going to fit. Chad, I don't think Tessa knows about the salami lid. It's a shame. There we go. To rephrase that, I'm interested to see if maybe the reason why the hinge is still able to spin as if it's in the housing is because the game only checks how much it can move in each direction the moment of the part is loaded in. Yeah, I mean, that seems to be what was going on there. Alright, so this is pushing 280 tons. I want to see what this does. This would break. This would break the old drive. I know this would break the old drive. Does she know about my boat? Do you know about my boat? Hey, we're not coughing. Yo, I'm not coughing. Just on a side note. Just quick side note action right there. Not coughing. Set position. Let's go up here. Now that I said something, don't jinx it. I thought about it. Guys, I thought about it. I'm sorry. Forgive me. Alright. Minimus. You jinxed it. I did. I totally did. Cough less, though. Yes, let's focus on coughing less. Okay. Alright. Okay. 1. Fuel cell is on, which means we're colliding. Alright. What is this thing going to do? Let's get aligned. Alright. Let out the clutch. Slowly. Bruh. Didn't like it. Okay. All right. That was a bad one. Skippity bop. That didn't like it. It didn't like that. Okay. Shh. Crack and drive. Just chill. Big Smoke, it's me, Carl. Chill. You picked the wrong house, fool. I'll take 2 number 9s. Number 9. Damn it. I said I jinxed myself. Now I'm thinking about coughing, and now my body's like, oh, I see you're thinking about coughing. Would you like me to help you? No, Clippy, go away. It's because the salami lid is colliding with my Lamborghini.
Discovery, go and throttle up.
Hey, there he is. 30-month resub. That looked like dropping the clutch. Yeah, pretty much. I'll take 2 number 9s. A number 9 large. A number 6 with extra dip. 2 45s. And a drink. What? Okay. Okay, let's try this again.
Discovery, go and throttle up.
It's a me! Go spinny thing! Yes! Go cyborg! Min miss. Set min miss. Hit 1, fuel cell, online. And just so we don't screw with the payload. Alright, so this is the drive. pushing 280 tons. Let's see what it does. All right. Slowly. Let out the clutch. Slowly. Come on. Come on. Push it. Ah. Push it. We have Pogo. 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 Ah. Ah. Bruh. 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 Are we getting any acceleration from this thing? Nope. See? See? Like I said, it's TWR based. This thing will not, it doesn't like pushing this much. Maybe we gotta spin the drive faster.
Discovery, go and throttle up.
Nope. We shorted it. It doesn't want to move it. The stronger piston, that piston is overclocked, dude. It's way overclocked. It's like 700 times its force. What about a Kraken drive land speed record? It doesn't work below 400 meters, Cyborg, for whatever reason. Can you overclock the engines past 460%? Yeah, no, it didn't like it. It didn't like it at all. So is the next attempt with a smaller mass? No. Yeah, Tessa, we could do that. Or we could make the salami lid fit. I'll do that, Jason, yeah. We'll do that too, just to be sure. I just frickin' jinxed myself. I can't believe that. Thank you. Be like, bruh, 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 bruh. Actually, you know what? This should all dial it out. You know the trouble we've had with double drives in the past. Yeah, but hybrid tech. Hybrid tech, Tessa. You're not thinking fourth dimensionally, Marty! The salami lid. The Kraken drive won't fit. Ain't gonna fit. I think scaling up the drive is better. I want to try to make a bigger one that has spectrometer, that has the spectrometer The spectrometer hinge is in it. It'll make the salami lid fit, Rose. You don't understand. You don't understand. No. You don't understand. Alright, let's see what two of them are going to do. Spin these drives up to maximum. Deflector shields up at maximum. Alright, ready? Push them. Come on. Let me just get one of these up. Toggle display. Oh, it worked for a second. It worked for a second. We got it. It did it. Corbin, it moved. It worked. That pushed for just a second before we shorted it out. Scale the drive. We're scaling the drive. I'm making the drive bigger. I'm going to start fresh. We'll make a bigger one. Alright, anyway. Get rid of all this. Alright. Okay. Fairing. How did I do this? Rotor. We need a rotor. Biggest rotor you got. There we go. Alright. Rotor. Rotor's gonna go right here. We need our science tool right here, like this, to measure our acceleration. Right? And then, what did I do? You know what? I got another idea. I got an idea. That's a physics-less part right there, isn't it? So take this, attach that to the physics-less part. And then put these in 4x symmetry and move the struts back off of the physics-less part like this. Right? And then we're gonna go here like this, move this up like that. Perfect. Okay. Now, let me grab a 3p6 hydraulic. Right? That'll work. That needs to attach to... Oh no, the rotor needs to spin. The hydraulic needs to spin, doesn't it? Yeah, it does. So that needs to be attached there. Okay, cool. Now push this back here like this, take that like that. Now, give me an RCS ball. And we are gonna spin stabilize the back part of this rotor right here. Nah, Tessa, we good, man. We alright. Is EJ sick? EJ's getting over the Ronies, dude. Yeah, that's why I'm coughing. I'm fine. I'm way over it. I had it 2 weeks ago. It's just still got a cough for some stupid reason, but it is what it is. I'll be alright. I'll be alright. I'll be alright. This is gonna make it worth it. Viruses do be like that. Hard to believe that K drives are 5 years old and that KSP is 10. You. Yes, you. Stop talking. Don't do that again. Don't do that again. Don't do that again. Don't do that again. Here we go. Give me that. Ronies. Stop, Chad. Give me the Ronies. Any trick to making those barrel casings? I spent one stream like 7 or 8 years ago, literally 95, just tweaking this and making sure and fine-tuning it. That's the key. You just got to be patient till you get one that works. The tolerances are very specific, to say the least. All right, so let's get our clutch plate. Where's the clutch disc? We need this thing. Nope. This one. Maximum dirt. Alright, move that back through there. That needs to have same vessel collision and it needs extreme grip. Now here's the key. Here's the key to how to build these drives. Grab these things, right? And these things need to be the drives that we've been using were in 6 times symmetry. We could switch it to 8, but spring set to 0, set damper to 0, deploy shielded, same vessel interaction. So boring. Yeah, whatever. Typical instant gratification salami lid. We could do 8. 8 might work. Oh, this thing can't have any damper force. That's no good. And the motor size. So, with our old drive, we had a 1P2 hydraulic cylinder and it was at 600%. We might still need to do an overclock, so. Ogre clock. Ogre clock. Ogre clock. Pull up. Okay. So now give me another one of these. Give me one Lamborghini, and then another Lamborghini, and then give me 47 Lamborghinis. Okay? I need 47 Lamborghinis in my Lamborghini account. The salami lid... Wait, it does fit? Oh. Well, shoot. Enable same vessel collision. It's already enabled on the original part that I copied. Enable SVI. Enable SVI. Enable SVI. Enable SVI. Good. 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 Save. Marlboro is how I say it, Panta. Well, that would be me on stream. Marlboro. Almost like Maul, like a Maul, like Darth Maul. Marlboro. Yeah, that's how you'd say it. Overclock. So, overclocking hydraulics is pretty fun. You want this thing to be stronger than its output. I think it's 400 kilonewtons. Want it to be stronger than that? Go in here. Click on the cow controller. Or, yeah, click on here. Go to force limit. Go here. Take this. Go over here. Move the cow controller right into the center. And it'll pick up the curve right there. And it'll apply like 600 times the force. Yeah. Yeah. You want to make really strong hydraulics. It's a good way to do it. Make sure you get batteries when you do that, because batteries. Great VODs on YouTube. Keep them up. Thank you. Okay, so now we do need to go back into action groups. I need to go here. Stop. EJ had a RAM error. Target extension, adjust input rate, incremental input, really low. And then I need left and right for this to change the torque limit. There we go. Fuel cells. There we go. We got our fuel cell. But we need batteries. There we go. There's the battery. It's good. It's good. Would you maybe want a second cow for a slower engage? We could do that to get a more precise engagement. Yeah. I mean, if you guys want to do that, that's fine. Let's go. Get rid of the target extension. Control rod actuator. It's like a nuke. You gotta close the control rods. Or, well, nuke's opening the control rods, but I digress. Alright, go in here, go to target extension, go here like this, take that, move that up like that. Actually, we want to start at maximum extension, and then, yeah, there we go. And then we set it to like 30 seconds, a 30-second incremental right there. And that should keep it nice and smooth. And then, if we go over here, go back into action groups, take our control rod actuator, bind that play position to forward and back, and set incremental 1% control play position. That'll give us really fine control over the actuation on this. Same vessel collision, same vessel collision. Okay. There it is, guys. Now I started coughing again. Now I'm thinking about it and I'm coughing like crazy. God dang COVID. Okay. All right, we should be good. Let's do this. I'm wondering if this thing is going to start spinning around. Yeah, you know what? You know what? No. All right. Let's just put the thing out and see what happens. I'm watching, but I'm too dumb. How does it generate acceleration? Push on a landing leg with a grip pad. It's a me. You ever load into KSP like at your moon base and something? You have a lander that's sitting on landing legs and it just blows up and shoots up into the air. Yeah, Kraken strikes, right? We found a way a long time ago to harness it into a drive mechanism. And this drive mechanism can make you go like 0.5 C or something, which is absurdly fast. Okay. We're gonna need a contra rotator here. Oh my goodness, it's so slow. We'll know if this is working despite being below 400 here. We'll know it's working. It'll just start kind of... Here we go. Oh, the engage is so smooth. Oh! Look at that! What the frick? Yo, look. We do not have hack gravity on. No cheats are enabled. That's awesome! That was awesome! That was awesome! That was awesome! Yeah, Shady. Yeah, that's what that means. That was, dude! That was sick! Very, very stable. Very stable. Very, very nice. Could you turn on the lift control? That's really cool, but I wonder if it could be acting as more than a propeller than anything else. What's the... It's not, but... Okay. Yeah, someone... It's not, dude. I'm pretty sure. Alright, so now I'm just going to take this, set that one to counterclockwise. How do you set it to contra-rotate? Right-click on it and set counterclockwise rotation. We just got to make sure that the action group's transferred over. Looks like they did. Counter-rotating drives aren't a guarantee. They're not an end-all be-all for this thing to work, dudes. Just on a side note. We never figured out why it's 400 someone. I don't know. It's some kind of optimization in Kerbal. And I know that's not propellers, dude. I know it's not propellers. I could spin the drive without engaging it on the ground if you want, and it wouldn't do anything. It only started moving after we engaged. So I know it's not propellers. We know it's not doing that. Okay, ready? Okay. The torque should cancel it out completely. Yeah, the torque from each one of those is canceling each other out. Let me just make sure my actuators are working in sync. I broke this. The action groups aren't working. Hold on. Give me 1 second, guys. I have to, I'm gonna bind everything to one Cal controller. Overclock. The hell? Huh. That's... I'm not gonna ask. Whatever. Overclock. Go up here. Force limiter. Yeah, copying the cow controller like that, it did not appreciate it. Alright, let's try this now. So how many can you link? We really should only need 2 here, man. Can we name the first ship Event Horizon? Yeah, maybe. Okay. Ready? Spin it up. Okay. Contra rotation is working. We have next to 0 roll rate. Okay. We are engaging the drives. Fuel cells. Fuel cells should be engaged. Okay. Fuel cells are engaged. You're gonna make the Enterprise? Maybe. There's your lift indicator, someone. Okay. We have good engagement. Stand by for full compression. Nope, nope, that's not a good idea. Stand by for full mesh engagement. Hybrid tech. Hybrid tech contra rotator. It's about to engage. Here we go. What the absolute frick? Keep in mind, we're still below 400, guys. But also, we literally have made a repulsor lift from Star Wars here. Yeah, once again, just in case anybody thinks we're full of crap, look. No cheats. Nothing. No cheats. This is all legit. It's all in a legit game. This is how UFOs work. Yes. Now you guys know why I spend my time sitting here engineering rockets all day. Because I literally have a drive that can go anywhere in Kerbal. It's like having Rick's portal gun, man. I am God! No. False idolatry is bad. Is bad if you're religious. Yeah, I'm a dork, I know. I'm lifting it with my thoughts. Tessa, look at how smooth it is, dude. The hybrid tech Kraken drive. But I am God. Praise the sun. All right, go faster. It's crazy. I can't believe, dude, it's I mean, the grip pad is moving a little bit. It's moving a tiny bit. Can we make one with 3 axles? We don't need 3, Wookie. They're contra-rotating each other and keeping each other nice and balanced out, dude. Look at our body rates. The roll rates are nothing. There's literally no roll rate here. Or there's no actuation rate. It's unbelievable. Can we make one in 3 axes? Oh. 3-axis movement. Why not 6? Could you make a VTOL plane with this? Yeah, of course. A helicopter might be a little bit easier to work. Guys, we're approaching 400. I'm not 100% sure. Well, no, I am 100% sure. We are going to shoot off like a firework when that happens. Slow down to 0.1. I agree. Bro, look at Tessa. Can you believe this? It works off graph center of mass. Phenos. So, yeah, it's graph center of mass. I can't believe it. Hybrid tech, man. Hybrid tech is the game changer. Dude, these, depending on what happens here in another 15, 20 meters, I might consider this. I might consider it. You guys want to go to Elu in real time? In one stream? We can do that. Oh, we could do that. Yeah, we could do that. We'd get there pretty damn fast. Dude. Hybrid tech, I made a helicopter fly on one Juno. One Juno. I know, Luizo. I know. It's so good, man. This is what we've been chasing, dude. Look at this. This thing is hovering. That's awesome. The hover is so cool, dude. Okay, here we go. All right. I'm scared. Chad, I'm scared. Hold me. Past 400. The hell? That's right, MGB. Huh. It might be ground altimeter, guys. When it goes, Tesla, yeah, oh, she's gonna go. It might be ground altimeter. What the heck is this? My calculations are correct. When this baby hits 400 meters off the ground, you're gonna see some serious stuff. We're past 400 ground. I don't understand. Oh! That was awesome. It did it. Dude. You don't understand. These boys killed my dog. Come on! Go! Fly! Help! Hold me! Hold me, Jen! Help! Oh! Whoa! Yes! That was awesome! Warp core coolant leak! Jettison the saucer section! Call in the Navy! That's awesome. That was awesome. Now add wings. It's like there's a threshold or something. She needs some SAS. Yeah. Yeah, Tessa, that probably is a good idea. Here, we'll give her a nice nose cone too. There we go. And some wingalings. Get a little wingaling. That looks good. Coming out of the back of its neck there. That's good. There. Ah, control surfaces. Nice. We might want to auto strut those. Okay. Can you overclock SAS? No. Does closing the will closing the fairings affect performance? Yeah, of course they will. Yeah, of course that will do that. I mean, I could. I like seeing the guts. Hold on. I like seeing the guts out. That's funnier that way. Put a couple of engines down the bottom so it gets up to altitude quicker. Where's the fun in that, Tessa? This is just a normal rocket. Nothing to see here. No, it's fine. Right? Imagine if we had see-through fairings. Yeah, that'd be pretty cool. Make it a bell shaped like die Glock. Oh God, no, not that freaking thing. Yeah, freaking. I'm gonna make a flying bell. Sure, why not? Fuel cells. Welcome aboard, Captain. All systems online. Alright, let's toggle the overclock just to be sure, and then
Discovery, go and throttle up.
wait for it. Chris! 70 months. Where did the time go? I don't know, man. Set to radial out and unbelievable. All right.
Discovery, go and throttle up.
Push it. Push it. Push it. Push it. Ooh, baby. Sorry. Salt and peppers here. You ever sat and pondered its beauty, its brilliance? You ever stared at it? Hey, someone 24-month resub. 2 years, that's more than one. The low altitude speed limit is just the inertial dampers. Yep. Where we're going, we don't need eyes. So what happens when you hit 400 at full throttle? Yeet. It seemed that like it only really started to take into effect when I goosed it. That's when it started to move. It's amazing how much of a difference the Kraken bearings make. Yes, unbelievable. Physics-less parts, man. They don't move. It's ridiculous. It is ridiculous. Ridiculous. It doesn't freaking move. In fact, I could, with these, the spectral bearings allow the RCS to move up and down. I could actually add another set of spectral bearings attached to the grip pad, and that would make the grip pad not move. Oh, man. Yeah, Tessa, I think you might be right. We should probably test that. Here, let's slow us down. Let's disengage a little bit. Disengage just a little bit. And let's just chill. Let's just chill. If you could manually offset the two and the force makes everything around the COM rotate, does that count as gimbal? Yeah, maybe, I don't know. Look at that. Dude, I can't, you know what? I was saying like, oh, it'd be better if we used a helicopter. I can't make a helicopter do that. I can't, dude, that is not moving. We are not moving up. Once again, look at our acceleration. Degrees a second A, all right? Look at our acceleration. Nothing. We are dead still. Could you make a floating rocket launch pad? I could make a floating anything. First thing that pops into my mind is the Avengers Hellcarrier. Yeah, screw that. Dude, we could make anything. We could make a Star Destroyer if we want to. 2 fighters against a Star Destroyer. Well, and if you stick a jet on it, you can push it around. Well, Wookiee was talking about omnidirectional Kraken drives. Omnidirectional drives. If I have 3-axis drive, right? We have 3-axis drive. Basically put another set of these facing downwards, another set facing that way, another set facing that way, another set facing that way. We could literally make UFOs. All right, so sum it down now. Sum it down now. You're a UFO. Your mom's a UFO. That's ridiculous. That's ridiculous. We're not moving. Floating landing pad? Actually, you know what would be a good idea? We make a drone ship, right? We make a drone ship with these things, and right, we fly it out there using this as like a ground, using this to fake the ground effect, right? We use that to fake the ground effect, and then we park it in the ocean, land the rocket on it, right? And then lift it up out of the water and fly it back. It would work too. That's the funny part. It would work. And then, the drone ship gets here. Oh, we need the booster there. Oh, just lift the drone ship up out of the water, park it down on the ground. I'm not sure, Wookie. I mean, maybe we could do that. Time to upgrade the Pelican. Dude, screw that. We'll make the Millennium Falcon. You never heard of the Millennium Falcon? Should I have? Yeah, a crane. Yeah, this thing could just go pick it up. Okay, move it back over there. No problem. Tessa, I think there is somewhat of a speed component to it, dude. Look, I'm just sitting here. It's 0. It's ridiculous how... Can you right-click the landing gear for me? What about it?
Discovery.
What
no
about it?
throttle up.
What about it? You big whoop. Want to fight about it? Phil, 61-month resub. It's the ship that did the Moho run in 12 parsecs. Isn't a parsec a unit of distance, not time? It's a really fast ship there, Luke. Tessa, there's definitely a speed threshold component here. Alright. Time for Yeetus. Biggest Yeetus. Wait for it. Wait for it. Oh, bro. Okay, alright. Stop.
Discovery. Go at throttle up.
Alright, let's just chill. Tessa, I'm gonna test something. I'm gonna try to see... I want to try to see if this thing hovers. If I can get it to hover up here. Why not bind it to the throttle axis? A Cal controller with H and N will give me better incremental control than that would. Hang on, we have a little bit of a horizontal component. What the frick? Yeah, dude, there's a velocity component involved here. There has to be. There has to be, dude. Bada boom! It's there. I saw it. We went below a certain velocity, dude, and then the thing locked to 0. Did you see it? Bada boom! What happens when you time warp? Nothing good will happen when we time warp. Yeah, 5 meters a second. Yeah, you saw it go below 5 and then it went Dude. And now let's see if we can now let's see if it's back to fine control on with the altitude. Yep, it is. It's now I have fine control. You want to go down a little ways? Let's go down a little ways. As long as we don't exceed 5 meters a second, we're good to go. Dude, look at that. I gotta see something. Let's look at this way. Does this think that it? I'm wondering if it thinks like if it's landed or something. Nope. We can float at any altitude. Yep, pretty much. Alien technology. Kraken technology. What's the water point? 0.5 meters a second for the friction component? Yeah, something like that, Tessa. Why? Now floated up at 80K? All right. Yeet! All right, that's enough. That's enough. That's enough. Stop. Stop. Slow down. Slow down. Slow it down. Oh, no, 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 no. Dwight, go back to surface. That may have been a little high. Oh, I wanna add, we've used like 400 units of fuel. And yeah, we're like maybe at 1/120th of the total impulse of this thing. Yeah, it's like, yeah, basically we've used nothing. See last, what's up? Alien tech. No, Kraken tech, I told you that already. Oh yeah, that's right. No, I was looking at electrical charge. Please excuse me. We've used 1/1439th of fuel. Yeah, it's just the price of keeping the fuel cells going. Because these, Tessa, look. You want to see the crazy part? Those things aren't even spinning very fast. They're using nothing. Dude, that's not okay. Goose it? No. I gotta see something. I have to see something. This is important. We're in engineering mode, Eukerman, but yeah. No, we're just in engineering mode. Last, is this a new Kraken drive? It's Kraken drives with hybrid tech bearings, and it is literally one of the craziest. Dude, we made a Trimaxian drone ship. That's what this is. It's a Trimaxian drone ship. Are you gonna try to get it to think you're landed in space? I want to see it. I want to see what happens when we hover up here, someone. And I want to promptly see the game just go. Huh? What? Yeah, pretty much, Shady, right? We just gotta wait for our speed to go down. See, if we had another set pointed down here, make it hover at Geo. What? It already... that wouldn't do anything. We can make it hover at any altitude, theoretically. Look! There goes the station. Next, you must hover in solar orbit. What is a Trimaxian drone ship? You'll see. Oh, that's the direction that we're going. Hold on. Alright. Pulsing the drives a little bit. We're at 1G of acceleration, give or take. Tessa, I think the game will explode when we get to lower speed. Set it back to radial out. Now we're going straight down almost. So with that little power usage, would solar be effective? Yeah, pretty much. Come on. Come on. It doesn't lock in up here. Hey, phone sister. I think that lock-in stuff is only below 70, but we're pretty much stationary. Stationary relative to curb, and what about Sol? I don't know. It's hard to, once again, I think it's above 70 that it screws up like this. Need finer control. We're just hovering. I'm not sure if changing it to orbit is a good idea, dude. No way. No freaking. Oh, we had it. It's much harder to get it done up here, Tessa. Much harder. Oh, that's so freaking cool, though. Look at this. You stand by it? Looks like it didn't really make much of a difference, Mammon. How far from Kerbin can it work? Pretty much anywhere. All right, you guys want to go to the moon? You guys want to see what this thing can do?
Discovery.
Could this
Go
turn
and
into
throttle.
elevator tech? I mean, it could. Oh, hi, moon.
Discovery. Go and throttle up.
Core space 50 and Demon with a 65. Thank you. Ah, yeah. Oh, yeah. Oh, nice. Very nice. Very nice, steady acceleration. Look at that. All right, let's go. Acceleration's holding steady at 7. We're orbital. All right, push it to 10. Something didn't seat right. We gotta spin them faster. We are pretty damn solid at 10, though. Doing a slight disengage on the drive so we can reestablish target. I see the drive plates, Tessa. We got to put them on a bearing. They're riding a little bit, just a little bit. We're past 6,600. Oh, we're way past escape. We get to the moon in 30 minutes at this rate. G-force indicator is up there. Maximum G's encountered is 10 thus far. Tessa, let's spin these things up. Spin them up. Get them to maximum RPM. Disengage the drive momentarily. Allow the controllers to reseat. All right, let's go again. Okay. We are holding steady at 5. We have a little bit of oscillations on both wheels. Engage the silent drive. Over 9,000! Increasing acceleration, 6. 6 Gs, totally stable. Disable the fins? I don't know what that's gonna do, but alright. Interesting. Alright, let's push it up to 10. We're at 10 Gs of acceleration, 12,000 meters a second. Getting slight deviation here. Yeah, we got to find a way for those to stay true. Tessa, it looks like the rotor is not oscillating very much. It's the hydraulic. So maybe I'll put a hydraulic RCS ball down here. No, Tessa, that's what we gotta do. We gotta attach an RCS ball to that grip pad, and we gotta put another one down here. Other than that, dude, this thing here, I'm gonna push it. 12, 15. Where are we gonna go before this thing breaks? Yeah, it broke. There we go. It didn't like beyond 20. Disengaging. Insanely cool, Jackal. My favorite speed limit sign I ever saw was at the Mount Palomar Observatory, and it said speed limit in C. Nice. Hybrid tech Kraken drives, Jackal. It's the future. We're going out to the moon. We're going to be there in 10 minutes. This thing loves 5Gs, though. 5G is perfect. I mean, and considering that's 5 with no RCS and minimal SAS control, you haven't even maxed out the torque on the SAS. And we're only spinning at 50%. If I just put these both up there... Oh, look at what happened. You guys see what happened? Okay. All right. Wait a minute.
Discovery, go at throttle up.
Wait a second. Wait, what the hell? The spin used to do something, 95. It doesn't seem to give an absolute frick right now. Why is that a thing? We're at 13. 15. 17. Slight deviation. 18, 20. $21, $22. Drive still hasn't broken yet. $20, $26, $27, $28, $29. We're at maximum extension. We broke. Yeah, I get you, Tessa. Yeah, I understand. Interesting. Okay. I won't deprive you guys of a lunar flyby here, so. Let's just do slight coplanar anti-normal. And yeah, let's get close. What the frick? I always had more luck with drives that weren't spinning. What are we accelerating? We're at 15. 15 solid. How do I get your playlist? Ask, hey EJ, where's your playlist? And then I can just link you the link in chat like I just did, man. It's a hybrid tech stabilized Kraken drive, Dr. Death. Guys, I'm not time warping, by the way. Yeah, that moon is... The moon's moving awfully fast. Kraken drive. We're at like 001C, guys. We're not close to moving speed of light. I made it out here with no rocket engines. No cheats either. Yeah. Hey, Moon. Bye, Moon. Yeah. Tessa, yeah, this thing is... Like, this isn't a cheat? I don't see any cheats enabled, do you? SOI transition. Dude, the fact that it pushes through SOI transition is pretty freaking cool. Well, we haven't done load testing on it, Demon. This is just kind of free. And all right, cool. Let's go back over here real quick, guys. I gotta test some things. All right, so the first thing that we're gonna do is we're gonna modify the hinges a little bit. We're gonna modify the hinges. We need an RCS ball on that hinge. But we need it for right in this area here. So let me put that thing to right there, and then give me an RCS ball. Hey, Ozzy, 76 months. I gotta test something too. Yeah. Well, Tessa, here's what we're gonna do then. If this is the case, right? If we don't do the spinny boy, let's do this then. Let's get rid of that. See what happens. If this thing stabilizes like we think it's going to stabilize. Put min-max extensions on the hydraulics so the drive is always engaged, but not on. I'm just gonna give it more throw. I'm gonna make it engage way past the push point, dude. Yeah, that's what we're gonna do. And I'll make it so right when we hit the engage point, when we hit the mesh point, that RCS ball should be riding in there. And if we did this right, it should just clip through the other ones. Should. If this is going to work how I think it's going to work. And let's move those in a little bit. There we go. I know that thing is sitting back there and it looks weird now. Let's see. Is it throttleable? Oh yeah. Oh yeah, very. Yeah, but the hydraulic cylinder doesn't have same vessel collision, Luizo. It's not a problem. Okay, Tessa. It is riding on the other ones. Tessa, why is it doing that? Why is it... I'm confused. Why is it just... Why does it go right to 0.5? And then that does that. Huh. The drive is stronger, so you don't have the precision now. Okay. Let's do that then. Nope. Nope. Try again. this one won't hover. You're breaking the laws of physics. I'm bringing you in. What are you? The physics police? Yeah, this one doesn't hover, Tessa. I don't understand why it's not hovering, but it doesn't. Whatever, let's go. Let's go for a ride. Oh, God. Oh, okay. All right. Damn. All right, fine. Go faster. It's that RCS ball. It's the RCS ball that's freaking it out. I think that might be the problem. You need to make it longer to be controlled like a rocket. What? Alright, I'm gonna get rid of that. Seriously. And then I'm gonna put these things back out where they were. They were one tick out like that. Alright, cool. Tessa, should we just rip the Band-Aid off and eliminate the rotor completely? Okay. Okay. I'm going to attach the landing leg. I'm going to cough a lot. And then I'm going to attach the landing legs to a physicsless part. And then we're going to flip, zop, zoobity bop, flip that around like that. Set those in that position right there. Like that. Set these to same vessel collision. Set the override. 0, 0. I could probably make this way more compact now. Now that that's the case over here, where's the throw? Maximum throw is well beyond there. We have about 1.6 meters of throw here, so move that in there like that. Take those struts, get rid of them, and then move this in here like this and give me an RCS ball there. Put one RCS ball on the grip pad. Set that grip pad to an absolute snap. Set that to an absolute snap. Okay. One RCS ball here at the end of the throw. Right there for the grip pad. And then another one on the hydraulic so it doesn't move. We're making faster than, well, not faster than light, but we're making magic here, chat. All right, ready? Oh. Well, there's no way that we're gonna hit this extension with this thing being stable. If that happens, I'll be very impressed. Set that, SVI. Go in here, make sure the RCS balls are set to the same vessel. They are. What about the front ones? Front ones are as well. Won't the grip pad with SVI collide with the bearings? No. It's attached to the bearings. This whole thing can be way more compact, but we'll just go with this open design for now. All right, Tessa. Let's see what this does. Shall we? Let's see what it does. Miniaturization comes with product maturity. Yeah, that's fair. Okay. Spinless design. We're set to radial out. Okay. Moving the control rod in. Wait for it. Should be happening right around now. Tessa, this one won't stay still. I don't want to get into politics, but what are the news concerning the ISS? Nothing. I don't know. I don't know. I don't have the answer there, man. I don't think anything's gonna happen. Is it crucial to floating? Floating is not really needed for anything, but that we need if we were going to use one of these things. However, I don't like that our upgraded design does less. Tessa, I'm telling you, every time I get near 0.1 meters a second, it just jumps to 0.5. And the legs start doing that. I'm not sure what that's about, man. Increase the cal more. Nah, you're not listening. We're at 300 right now, and it's still doing it. Here, I'll go to 500. It doesn't matter what the control is. You get near 0.1, and it just springs to 0.5 meters a second. Doesn't matter if you're decelerating or accelerating. See? The landing legs start doing that. Did you figure out a new Kraken glitch? Yeah, hybrid tech stabilized drive. It won't hover. See? Anytime I get close to hovering, it just bonks it. The double drive, which this is the same craft file, I overwrote it because I'm an idiot. The double spinny drive was the one that was hovering just fine. The landing legs, yeah, they start, like, when you look, see? They start doing that. Which is very weird. We didn't encounter that before. Yeah, that's very strange. Anyway, let's go fast. Click. I don't know, Tessa, maybe. Is this supposed to be fast? Yeah. Where's that damn moon? Oh, that's Gilly. Mun. Set as target.
Discovery, go at throttle up.
Engaging the drive. Got a nice smooth 5 Gs of acceleration here. Shifting our orbit towards the moon. It is! 14-month resub. Hey, Grizzled. It's going all right, man. How are you?
Discovery, go at throttle up.
Drive's looking good. Southern Gent, 54 months. Thank you. Have you messed with the damper or spring strengths? No, don't. They have to be set to 0. Okay, we got 6 Gs of acceleration. We're almost on orbit. Push it to 10. 10 is nice and stable. We're nice and stable. The drive is very, very stable. Pushing to 15. You got the salami lid stuck in your head. My fault. We're at 15. 15, we're still pretty darn stable there. Slight deviation there, but yep, she's still very stable. Pushing it to 16. We're on escape trajectory out of Kerbin. Passing 12 kilometers a second. 17. Still stable. Still very controllable. Pushing to 20. Still really stable. 18,000 meters a second. We're very stable at 20. Can you bring up the cal and pin it, please, Bows? Bows. Hey, Bows. Can I have the cal, please? 20,000 meters a second. Moon encounter in 10 minutes. Push it further. How far can we go? Push it to 25. We're at 25 Gs of acceleration and holding. 24,000 meters a second. Moon encounter in less than 7 minutes and closing awfully fast. I did not forget to activate the fuel cell. We're straight up sapping power. We can't do this for this long. Fuel cell is at maximum power generation. I'm giving her all she's got, Captain. I can't change the laws of physics, Captain. Ailerons work in space? No, those aren't doing anything. There's no air up there for them to move, Moose. 32,000 meters a second. Let's push to 30. 27, 28, 29. We have Pogo. Backing off. Lock back in straight at 20. See, Tessa, the ones that are spinning don't get Pogo like that. That Pogo is what's screwing it up. I mean, we're still going 40,000 meters a second. We're going to be at the moon in 3 minutes. We should probably turn around, actually. It's so stable without a rotor. Yeah. Okay, we have reached our cruising speed of 41 kilometers a second. We're go for the flip. Fuel cell only kicks in at 95% electrical charge. Yes. Moon encounter in 2 minutes. Start slowing down. Re-engage the drive. Re-engaging the drive. Drive re-engage. 1 G of deceleration. Moving right to 5. We're at 5. On the... I disengaged the gear by accident. That was my fault. Drive's not engaging. I screwed it up. Drive's still not re-engaging. We're closing in on the moon awfully fast. Drive re-engaged. We need to really hit the brakes here, dudes. Pushing the drive to absolute maximum. 20 Gs. We didn't see this. Something's broken. I hit G when I was trying to throttle the drive instead of H, and it broke it. Everything is misaligned now. Oh, hi, Moon. What's new with you? Houston, we've had a problem. Okay. All right. I can think of a couple of different design changes that we need to do here. Just if you just bear with me. Extra reaction wheels? Well, the reaction wheels are just a result of not making a completely smooth drive, Ian. That's the thing. Let's try to close these up. We'll tighten them up a little bit. We'll tighten these suckers up. And then make sure that the maximum reach for this thing is well out of the landing gear. Well away from the landing gear there. What is the purpose of the hybrid tech in this design? It makes sure that stuff doesn't move around like this. It holds everything completely straight. And speaking of that, I'm going to try something here. Strut the landing gear to the housing. I'm a little confused. Why won't the grip pad with same vessel interaction not interact with the spectrometers with SVI? Sometimes physics-less parts are just strange, dude. It looked like it was there for a second. Right there should be more than enough. Okay. Let's try this again. Funky T, what's going on? I'm a little... Okay, alright, I already read that. Okay. Yeah, hypersonic. The hybrid tech is holding it true. It makes it not... Like, the landing gear sometimes, like, push and bend the... It pushes and bends the grip pad, but I have the hybrid tech bearings holding the grip pad and making sure that it and the hydraulic are completely straight. And the result is insane. Tessa, I'm wondering if strutting the thing is what's going to fix this here. Here, let me just go in here. I wonder if strutting these is what's going to make it do. Also, let's go in here. Where's the gear? Just get rid of that. Make sure I do that back in the craft file in a second. Does it move when it shouldn't? Duct tape. Does it move when it should? WD-40. Do you want it to go really, really fast? Kraken drive. Okay, let's see if that fixed it. Is this too cheaty for mission mode? I haven't decided yet. Nope, still did it. It doesn't hover like mine. The spin stabilization does really help with vehicle handling. I got it, boss. The movement of the cow is based on a percentage. To make it more precise, you'd need to control the cow with another cow on a ramp, like reducing a ratio. Oh. Yeah, I get it. But, Tessa, what you're talking about, I still don't think is what's going on. I'm sorry. Whatever's causing that, whatever makes it do that is no good. Maybe if we do increase the damp strength, what happens? Yep. It didn't like that. Well, it uses electricity. Cow-controlled ratio. This got him. It uses electricity, guys. It has a consumable. It's not making anything out of nothing. In fact, if I didn't have the fuel cell there, we'd sap that battery pretty damn quick. Hi, predominant. What's new with you? How's your predominant life? Hybrid tech stabilized Kraken drive, dude. We ejected the warp core. Yeah, Erod. Yeah. Watch. This one is using hybrid tech to hold everything completely in place. This thing is nuts. It's insanely stable. This is pretty neat. Well, that's pretty neat. Here, I'll shut the fuel cell off. I'll show you what I mean. I double drive. Yeah, like I said, Tessa, the double drive hovered. This one didn't, which is interesting. I really wish I could go back and grab that. I should have saved that craft file. That was insane what that thing did. I hovered the thing at like 15,000 meters. We were just hovering there. Like, these numbers were 0. Like we were sitting on the ground. Actually, it's pretty much what it is right now. Is that thing, is it? I mean, it's reading 0.1. Are we going up? The acceleration rates, everything is at 0. We're moving slightly sideways. I want to go fast. So about the EC usage? What about it?
Discovery, go at throttle up.
Go fast? Okay. Is it supposed to do that? No. Prepare to get sick, just for a second. If perpetual motion was possible, we could do this in real life. Yeah. Yeah. Yeah, and if pigs had wings, they would fly. Hey, Whitney. How are you? Great, and you? I'm good. I'm doing all right. Right there seems to be the sweet spot. Let's go. We could do this in real life. Just put a black hole on a stick. Infinite acceleration. Yeah. Yeah, it'll work just fine. Did you disable the gear? Yeah. Yeah, I did. Alright, let's see what we got. Thought I did that in an AG, but apparently I didn't, so now we're good. Okay, ready? Whoa. Cool. I hate it though. It's not really doing what I want at all. Wait for it. This one is slightly damaged. Are you kidding? Whoa. What the frick? 35. 35? We don't have the fuel tank attached. It has to be that. Holy crap. Approaching G limit on parts. What the hell? Wow, that thing was booking, man. We were approaching the G limit on the parts. The parts couldn't take it. You know how ridiculous that has. That's nuts, man. Okay. All right. I'm just going to get this thing right up into space, okay? How dead would you be at 40 Gs? It depends on how long that lasted. Guys, it's time to do those mass tests that we were talking about. Let's take the wings off. We have our fuel tank in the back there. Let's see what this looks like moving 81 tons around. Close that fuel tank out. Grandparents strut it. And then I'll get that RCS out on here. Put the RCS out at the front. Save. All right, ready? We're starting with 81 tons. I mean, 40 Gs is probably not a good thing. But it really depends on how quick you get to that acceleration and how long that acceleration is. If you go from 0 to 40 Gs like that, it's gonna hurt. If you go 0 to 40 Gs sustained, you're dead. Hi, sir. Are you there? Strimmer, hello. Yes, what, yeah. Hi. What's up? What's up, dude? I've not been here for a while. Okay. Hi. I already said hi to you. How are you? Sorry about that. I've been like this lately. Okay. Been like this after no Twitch for a while. Anyway, I'm fine. Oh, okay. That's good to know. Watch this. Here, maybe this will put you in a better mood. 81 tons. All right, let's get our accelerometer out. Toggle the display. Put that there like that. Wait till we get an acceleration tick here. Come on. We're starting to move. We're under 1G. 1G of acceleration. Okay, 1G moving 81 tons. Not bad, not bad, not bad at all. And we... Yeah, okay, good. Okay, I was wondering why the camera changed. Alright, push it. Pushing it up to 5. We are at 5 Gs of acceleration. Getting a little bit of deviation there from the drive. We broke a leg. We broke a leg. Damn it. Legs popped out. That's what happened. Can we do the math to figure out the specific impulse of this given it uses fuel cells? I'd be very interested to see how it compares. I don't know how we would calculate it. Someone. We'd have to look at the electrical consumption rate. You'd have to look at the electrical consumption rate of when the drive is throttled, and then you'd have to look at the power generation rate of the fuel cell and how much power that the fuel cell will generate with that much fuel. Remove the landing gear toggle. Yep. Should name it the Hamlet since you don't want to break a leg. If we make a ship Wookiee, maybe. You can name yours Hamlet, dude, if you really want to. It's a Kraken drive, man. See, this is what I mean. These Kraken drives don't like pushing stuff. They don't like moving a lot of mass around. Unless we were able to, like... I don't know. I don't know how we would make it stronger, but... Let's just take it right up into space. The moon. Yeah, I said it. The moon. So I'm not stopping at the moon. Peg that window. Get our accelerator up. Toggle. All right, here we go. Ready? All right. Stand by for the interfacing point. Okay. You got it. I had a feeling that's what was going on. Tessa, this drive sucks. I want my spinny drive back. Double up on the legs, boss. I don't think doubling up on the leg is going to do anything, Tessa. Wait, what are you talking about? Hold on. Are you talking about for like straight strength?
Discovery, go and throttle up.
Well, why not this many? That's 24. What are we gonna do? 24? That might end very poorly. I'm gonna get rid of that, to be honest, and then I want to see if these things ride correctly. I noticed that we were having some issues with it. I had this thing up to like 35 Gs, but that was with no fuel tank or nothing. Tessa, I don't know what the hell this is gonna do, but it's gonna do something. Same vessel collision. What the frick? What the frick are we doing here? Honestly, what are we doing here? Hybrid tech stabilized Kraken drive, Ivan. Yeah, Wookie, that's exactly what's going on. Yeah, that's what's happening. The question is, does the mass change how much you can retract the piston or just slow the acceleration? Standard TWR rules apply, Wookie. All this thing does is apply force in one direction, just like a rocket engine. Coughing is back. The coughing is back. Dang it. Okay, guys, here we go. Let's get the accelerometer indicator up. How many legs was this? 24? Well, this is gonna do something. Okay. We're at the threshold. Okay. We got a little bit. .4 G acceleration. Here we go. She's going. Pushing her right up to 5. We're at 5. 5 G's of acceleration. Approaching escape velocity. Yep. Okay, we are around the sun. Alright, let's keep going. We have Pogo. Slowly. Slowly push us past 5. We gotta slowly ramp on the drive here. 6 G's. There's Pogo again. Trying to reach the speed of light or something? No. I'm just trying to see. We're trying to load test this Kraken drive. I don't think I've ever made a Kraken drive move 81 tons. Once again, this is the hybrid tech stabilized Kraken drive. There's bearings that are holding the drive in place. And it really makes a difference. I mean, we're only going 7,600 meters a second. And we've consumed next to nothing. Let's see if we can get it past 6. Pogo. All right. This might be a really great idea, or it might be a really not great idea. This produces 1.49 giganewtons of force. That instantly drained my battery. Instantly. Because I'm thinking that the hydraulic force is the reason why it's pogoing Tessa. Let's get her done. Ready? Where are we? Oh, we're over here. All right, moon, set as target. Go towards the moon. If we pogo this drive, we're dead. We're gonna be out of fuel very quickly. Okay. We're going past 5. Okay, we're at 5 Gs. 5 Gs. We're steering towards the moon. Here we go. Is this a throttleable Kraken drive? It's a hybrid tech stabilized drive, Ernok. It's using hybrid tech to hold itself in place. No spinning is needed. It pogoed. We're dead. We're dead. It's gonna sap the power every time I try to... Here we go. Alright, we're pointed at the moon. Engage. Engage. We're at 5. 5 Gs of acceleration. This is gonna break it. But it's 81 tons, Tessa. It really doesn't like it. It doesn't like pushing it. Let's try that. Yeah. Okay. Too low power. Yes. Yeah, I know, man. I know. I mean, dude, this thing likes pushing. It doesn't mind pushing at 5 Gs. It could push at 5 Gs all day, Tessa. Like, that's really not an issue. I think that just might be the upper echelon of this drive's capability. I really don't think it can go much further than that. And that's 5 Gs at 81 tons. That's pretty damn good. I just think that's... I don't think it'll go further than that, dudes. The bigger gear makes a difference, Mank? You think so? I mean, this thing will sit right at 5 all day. The big ones have more oomph, Mank? You think so? I'm trying to figure out what drive would be best suited for a larger ship. You know what I'm saying? Guess picking up what I'm laying down. I mean, this thing is nice and happy right here. About 4 to 5 Gs acceleration. It's nice and happy. We're taking a right-hand turn. We went out here and now we're turning back towards the moon. I don't know what you're talking about, Ivan. I don't think hydraulic was the hydraulic strength was the thing here, dude. Could you use 2 more of those drives side by side simultaneously? They like to point through the center of mass, Ponzister. But yeah, you should be able to. But see, like, I can't help but think in the back of my mind that we got the Nautilus to go way faster than this. I subtracted 6. I turned off SVI on 6 of the gear right there, Tessa. And it did not change my acceleration rate. What is the rate of fuel consumption? Look at it. It's up there in the top left. Pull another set. Okay. Now, see, we saw deceleration there. There's... What the frick? Hold on. So we're at 3.9. Enable SVI there. Oh, and it went up to 5. Oh, no. Okay. Okay, no, I'm wrong. Yeah, the amount of legs does absolutely make a difference. That pretty much proves that. Where are we? Oh, We're pointing at the moon. Very nice. So there's a correlation suite. We can count the... Yeah, exactly. Mm-hmm. All right. Pull it back out. What I want to do, fellas, here is this. Watch. Let's put a maneuver node down just to see. And let's pull... Let's tug on that damn maneuver node. Let's see what happens here. So we have a 9,000 meter a second burn right here. Ready? Find the maneuver. Set this thing to target the maneuver node. Set this thing to target maneuver node. And you guys want to see what this thing can do? Watch this. Ready? Warp it all the way out here. And then... Get rid of that. Hit it. Okay, the drive is engaged. Watch the maneuver node go down. Keep it right at 5 Gs. Actually, you know what? Let's push it. See if we can go any faster. Go faster! Oh nope, she started pogoing. Back it out. Yeah, Tessa, this one likes right around 5 to 6, anywhere in there at 81 tons. It's pretty good. Now, like I said, I would be wondering what happens if we I'd be wondering what happens if we maneuver node going down. If we use different legs. Mank, you think the other thing that you looked at was making the backplate gear push against the deeper to try and prevent the gear clipping, though. Okay. It's whatever you want it to be, Kick. We're at 6. 6.1. I want to see if we could slowly ramp it, see what happens. Yeah, the drive is starting to deviate. We will not deviate from your present course. What's the exact mass of this bows? 89 tons exactly right now. Wow, we've used up a lot of fuel. Is that... Yeah. Dude, yeah, no, this drive uses up a lot of fuel. When it's working like this, she's using fuel. That's our drain rate is 0.5. It's not the RCS? Oh yeah, I suppose it would be that. That's our rate right now, but I can't maneuver. I can't maneuver with this. Or can we? Hold on. Yeah, it really doesn't like that. Yeah, I forgot the RCS was on. So this is a Kraken drive. Yep. Yup. You want this thing to impact the moon? Oh, okay. Yeah, I can make that happen. I just don't understand why this thing wants to deviate so much. I think it's just because we're pushing mass, dude. But it always just wants to go, it wants to yaw left, strangely enough. What's the mass of the ship? 80 tons. I mean, this thing is pretty good. It's moving pretty good, actually. Yep, 5 Gs of acceleration. Oh, we have a perigee. Or parasynthian, I should say. Yeah, 1 G of acceleration, this thing is totally controllable. The SAS is enough to hold it in position. He said as it just drifts out of position. I think it's getting pretty wiggly at about 22 point. It's like it's good for 22 tons. Man, I hope we hit a low point. I hope we hit a low point. Because, yeah, we're coming in real fast. No, there's no way. Mank, what gear were you using? Yeah, we hit a we hit a low point, all right. We made a low point. Yep. Congrats, you knocked the moon out of orbit. The big ones, the biggest gear. Were you using landing gear or landing legs, dude? All right, let's get rid of this. Alright. Let's try 6 of these. What are 6 of these gonna do? Let's see if there's a difference. FYI, I don't know if you saw that earlier. I want the camper special. Curious to see what he's gonna do with it. Dude, that's... Ernock, that's my truck. That's tough enough as a 3/4 ton 4x2 with a long bed. It's my truck, dude. I'm telling you. 3/4 tons are cool, man. You reached the moon! Congratulations! Mank, I don't think that worked. I don't think that worked, man. Ooh, dude, we might not have the throw with this thing. Oh, I didn't override the suspension. Oops. I was gonna do the dang smart thing. Will you be covering the James Webb image revealer? Is that not something you're interested in? What's a James Webb? Oh yeah, Bob, that's probably something we should do. Yeah, I know James Webb pic reveal and all that, and I'm gonna let you finish, but we all know that Hubble is the best deep field imaging thing of all time. That's not true at all, but, you know, also Kanye memes. LeVar is the best one of all time. All right. Cow controller's up. Accelerometer on. Flex capacitor. Flexing. Engine running. Push it. All right, let's see what this does. Okay, we've bottomed out the gear. We got no movement yet. Oh, we got some acceleration, just a little bit though. Interesting. That's what 6 of the small ones would have done. 0.2, right? Interesting. Interesting. Okay. Okay. Oh, hey, Lil. Hello? Input locks? Yes, this is dog. There we go. Okay. Time to get nuts. Time to get nuts. this will please me. Sir, you left the brakes on. Ah, crap! Ah, crap, I forgot my wallet. You want nuts, use the little nose steering gear. It technically doesn't have suspension, so it's pre-compressed. Yeah, Tessa, that might do it. I have hack grab on, just bear with me. Whoa. Oh, I lost the damn battery. Let me turn on that accelerometer here. Dude, it's accelerating right now. I didn't what the frick? It's just the batteries, we didn't need those. It pogoed. One of these pogoed at 5 Gs though. Okay. Alright. Hold on. Now that you put it out there, I think you were wrong. I think you did use the gear. Oh. Okay. Yeah. 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 Watch this. Hold on one second. One of those did what 24 of the small landing gear did, guys. One. This should be able to pick this thing up right now. We should be able to hover this tank. We should be able to hover 80 tons. Okay, set radial out. Okay, get my accelerometer up. Where is it? There it is. Accelerometer up. Okay. Hit 1 to make it angry for a second. Okay. Let's go. Yeah. Yeah, but this might also explode when too far from a point of mass. Yeah, I know. I know. Yeah, you're not wrong because its stress tolerance is only that. It's not 1 million.
Should we wait until tonight? The sweetest love is made by day. Feels right. Baby, why should we wait until tonight? If we make love in the light of day, feels right. Tell me why should we wait until tonight? The sweetest love is made by day. Feels right. Baby, why should we wait until tonight?
Wonder how the small deployable gear works. It's smaller and easier to place radially. Try with 3 or 4 of those so you can spread the contact points. Same vessel collision, Tessa. We can't do that. Crazy. Alright, let's see if we can get her flying. Ready? Damn. Damn. Wasn't enough. So this way tipped that way. So that means we gotta go. That means we gotta go right there with this thing. I think maybe we need to line up the landing gear shaft. I think that might do it, but I'm not sure. We'll see which way this gets affected, and we'll see if we can find like a mean point right there. Use 3. Same vessel collision. With same vessel collision, man, it's not gonna work. Hermano, escucha, por favor. Actually, it's rocket science fiction. Maggie, you are not good. Y'all are not good. Does that mean you're you don't deserve each other? I don't know. They weren't though, Tessa. I had them not clipped into each other. You ever watch The Expanse, Will? All right, I'll try doubling them, guys. I don't think that's going to work, but I'll try. Coughing. Yeah, that's the biggest grip pad, Bob, I think. I think we're using the biggest one already. Did it always tip in the same direction? It seems to be the case, Reboot. Yeah, we'll see. As long as you're coughing. Does not involve wheezing. Wheezing! Who's that Pokemans? Oh, God. Okay. Stabilize. Come on. There we go. Radial out. Come on, baby. No, come on. Could you use straight grip pads to get full coverage of the wheels? Yeah. No, Mikey, no, that is so not right. All right, I'm just gonna put this into space. We'll see what happens. What if we tried spinning it? Yeah, what if we did that? Oh, come on, man. Oh, damn, it's 10 o'clock. Wait. It's 10 o'clock. Wow. Okay. Shoot. Almost time to race, dudes. Damn. Where did that time go? Holy crap. Alright, let's find the moon over there. There's the mun. I think you're right, Tessa. I think we don't use landing gear because of the damn stress tolerance. Alright, Nick. I'll see you, buddy. Yeah, it's the stress tolerance, dude. That's what's screwing us.
Discovery, go and throttle up.
Hey, Yuck, 88-month resub. Thanks, dude. What in the absolute hell? Dude, it's so freaking powerful. Look at that. Wow, this is insane. It's nowhere near stable. Maybe if we hit the brakes, it'll stabilize out. That was nuts. I guess we jettisoned the warp core and we're on a trajectory out of the sun. Okay. Yep, that doesn't work. Those things are nuts. They're really freaking powerful. But yeah, it ain't gonna work. We had a warp core failure. It's basically an Epstein drive shrub. Yeah, that's what we've been up to. The small non-retractable gear are the most... These things? They're the best ones? You've had the most success with those? Interesting. The little ones are insane. Okay. Let's see. This is fun. I like doing these. I like doing these every once in a while. Just getting in here and building something nuts. You like big struts, but you need Mongo power to compress them. Lock the camera. Thought, what happens when you compress two parts that are being held apart by a strut? Tessa, that's what Mank just, when he said, I like the big struts, he's talking about the big landing struts, but Tessa, yeah, can you guys, I'm wondering, we know that these can generate phantom forces from float point errors. Let me move this into position. We're gonna need a lot of power. All right, let's just try this without the mass simulator. This could be the dark side. Do you want to mess with the dark side? Yes? No? Have I ever told you the story of Darth Jebius the Wise? Tessa, if struts don't work, now I'm wondering what is a fuel line going to do?
Discovery, go
Hey, Super. 73-month resub. Thanks, buddy. Okay. SAS on. Set radial out. Same vessel collision. Not that that matters. Come on. Take off. Come on. All right, screw it. We're going to 11. Jeez. Didn't work. Didn't work. Hey, Kix, what's going on? Thanks for being on. Jet lag's kicking your butt. What did I think about the Obi-Wan series? It was alright. Struts might inquire the system to work backwards. Yeah. Yeah. Yeah, maybe. That was promised an earth-shattering kaboom! Oh, Pembo, remind me, shoot me a message in Discord, dude, so we can get that thing figured out before I move. Yeah? You reminded me. Don't these grind drives require the quirks that landing gear landing like physics? Yes. Mm-hmm. Be careful when inserting the rods that have graphite tips. Come on. I mean, well, that looks cool. I'm not gonna lie to you, that actually is pretty neat. But that isn't anything we didn't know. How about using a physics-less part as the attach point to the hydraulic jack and then hooking the legs onto them? Like that physics-less part that this entire stream I've been attaching things to, Firework? Good idea. Yeah, Jacka, that's pretty cool. But I think Enraged Aries, a viewer, figured that out a little while ago. You can't daisy chain landing legs. They have no surface attachment point. I think I had the right idea, but on the other end. Okay. Let's see what that does. There's gear stress with those, Jaka. Gotta use landing legs if you want to go out further than the sun. Trust me, it's because of the stress tolerance. That's something we knew. That's why I didn't use landing gear. I remember now. You have to use landing legs if you don't want your Kraken drive to completely break when you're out by Elu. Okay. Yeah, no, that's not doing anything. Yeah, even going to the moon. Exactly. That was a pain in the butt, Tessa. Mm-hmm. Imagine a rod compressed of pistons and grip pads one after the other, then place the landing leg such that they compress one another. You'd have to build it, Wookie. It's getting late and I have trouble visualizing what people are saying late at night, dude. I'm not even kidding. Contra, yeah, yeah, okay, I understand what you're saying, but I'd have to test it. Try Tessa, we never tried the spinning drive. I never tried it with the RCS ball attached to the grip pad. We never did that. Suspension travel 0.8, 0.75, 0.95. All right. See, these have longer suspension travel, so I'm wondering what happens if we place down, okay, like, have a set stage amount there, right? And then go in here like this. There. You get 12 of them that way. These things have the longest suspension travel, so Tessa, I'm thinking you might be able to push these further. You know what I mean? Picking up what I'm laying down? Because I recall Bonana. Oh na 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 na. Alt F12 is the key for my debug menu. I think my settings file is old, so it may have changed. Okay. Okay, save this. Let's try something. I'm interested to see what this thing does hovering. Sorry, yawn. They have more suspension travel, Chief. I'm wondering if that means we can push them further. Because if you can push them further before they theoretically bottom out and start doing this, it should be better. Should be. All right, let's see. Radial out. Here we go. Same vessel collision. Come on. Come on. Come on. Here we go. You can do it. I don't know. Alright, I'm starting to get tired. Let's play some GTA, guys. Let's switch over to racing. Do some GTA shenanigans, wind it down a little bit. That was fun. You guys want to see more screwing around like that? And, you know, not like engineering mode and mission mode stuff all the time? You let me know. I have fun with stuff like that. That's cool. We should build that. We should get it to the point where we could build it into a ship, and we should get it to the point where we build the sucker out into a ship, like build a drive or build the drives and build a ship that they can move. Like, can you imagine a Grissom with those things, but like implemented correctly? Don't get me wrong, we've done Grissoms in the past with Kraken drives, but we couldn't engineer a drive that could push as much as we pushed today. You gotta remember, with that 24 leg variant, we were pushing 81 tons around, no problem, steady at 5 Gs. I'd be interested to see what happens though. Like, just kind of a conclusion, I'd be interested to see what happens though with that leg design